Hey guys, welcome to this session by Intellipaat. There's a very famous quote that says for every lock there is someone who's trying to break in, right? And the role of a cybersecurity specialist is to make sure this doesn't happen. Well, keeping this in mind, we here at Intellipaat have come up with this comprehensively put together video, the ethical hacking full course video just for you guys. Well, before we begin with the session, make sure to subscribe to our Intellipaat YouTube channel and hit that bell icon so that you'll never miss any update from us. So here's the agenda for this session. We'll start out by taking a quick introduction to what ethical hacking is. After understanding that, we can check out the phases of ethical hacking and also take an introduction to certified ethical hacking as well. And number 4 on the agenda, we'll take a look at the average income of a certified ethical hacker. And after which we can check out the ethical hacking tutorial configuration, footprinting with netcraft, net scanning with nmap, and of course network enumeration with netbios as well. And then number 9 on the agenda, we have vulnerability analysis with nessus, system hacking with lophtcrack, ARP poisoning with cain and abel, and number 12, we have ARP spoofing detection with wireshark as well. And moving on, number 13 on the agenda, we have phishing with SE toolkit, ddos attack with h.o.i.c, ddos prevention with the ddos guardian, session hijacking by making use of bettercap, and more. And of course, we have more as well because number 17 on the agenda discusses about honeypotting with honeybot, web server reconnaissance with httprecon, web application footprinting with whatweb, and SQL injection in detail as well. And lastly, we're going to be checking out how we can crack Wi-Fi passwords by making use of aircrack-ng and how we can create a trojan with njrat as well. And also, if you guys are looking forward to becoming experts in ethical hacking and if you want to become proficient in all of the concepts and clear examinations based on the same, make sure to check out the Intellipaat's ethical hacking course and CEH certification course made in collaboration with the EC Council. Well, now without further ado, let's start with the session.
So, firstly, an introduction to ethical hacking. Now, before we actually get to all of that, we need to understand what hacking is, right? So, hacking by definition is defined as gaining unauthorized access to a computer, system, or a network. So, basically, getting into some place where you don't have access by some illegal means or offhand means. And then to understand that diagrammatically, if you're a hacker and there's a target system that you need to hack, there will always be security measures in today's world placed between you and the target system. So you have two choices. The first way would be to bypass those security measures, and the second way would be crack those security measures. So that is how hackers operate all around the world. There are types of hackers, obviously. Not all hacking is illegal and unauthorized. So firstly, we have the black hat hacker. Now, the black hat hacker is a malicious hacker. This hacker could be after your money, could be after disrupting your day-to-day operations, or just in general, he means ill towards your organization. So this is the kind of hacker who is operating illegally without the permission of the systems or the people that he is trying to hack. And then we have the white hat hacker. Now, this is the polar opposite of the black hat hacker. This hacker hacks into systems with the permission of the owner of that system. And often the owner of the system has hired this particular individual to hack into his system. So this particular profession is a white hat hacker profession. This is completely legal as long as it is with permission. And then you have the gray area hacker, which is the gray hat hacker. Now, this could be illegal or legal depending on the laws of that particular country or organization or place. This hacker does not necessarily mean ill intent towards the target, but this hacker may not necessarily be operating with the permission of the people that he is trying to hack. So obviously the black hat hacker is an illegal profession. You shouldn't go for it. The gray hat hacker is in the gray area, so it is completely on your own risk. Whatever you do as a gray hat hacker, the recommended profession, if you're opting for this particular job role or this particular domain professionally, is to become a white hat hacker. That is completely legal. So let us understand what ethical hacking is. So, ethical hacking is the authorized and legal process of finding out vulnerabilities, threats, and exploits in a system or computer network through penetration testing. So, penetration testing means basically testing all of the flaws or exploits in a system which could make it vulnerable to attacks. Now, a white hat hacker is a ethical hacker, obviously. So the hacker hacks into the target system with permission of the owner of the target system. He compiles a report as to how he was able to hack into that system, all of the security flaws and exploits, compiles the report of that and sends it to the employer or the owner of the system. Now, the owner of the system can hire a security patching team to patch that flaw or flaws up, and then basically stay one step ahead of any black hat hacker with actual malicious intent. So the common hacks that are prominent around the world, and some of these we are actually going to be doing in our course that we have today. So the first is malware. We're going to be implementing malware. Malware is something essentially that is a unwanted file on the system which could harm your computer system or basically cause you annoyance or basically leak sensitive details of yours to potential attackers, right? So this is what a malware is. It can be a file, it can be an injection into your web browser. So all of those things are possible with a malware. And then we have phishing. Now phishing is a social engineering attack. We are going to be understanding that in much detail as we move along with our course here today. SQL injection, we're also going to be going over an example of SQL injection. We're actually going to be implementing it in one of our tutorials. And cross-site scripting. Now cross-site scripting is you go onto a website which is not entirely moderated. It is not recommended that you go onto that website. It is not a popular website. It's a very niche website. You go onto that, and then there's some pop-up, then there's some JavaScript that is running on that. So JavaScript is essentially an executable. So anything executable that runs on your web browser can potentially harm your system if it's not properly mitigated, or if your system is not properly protected against those sort of things, right? Because your web browser runs JavaScript code. So it's important that JavaScript code is not malicious, right? So whenever that code is malicious, that is called cross-site scripting. So it affects you on the client side, it runs on your browser, and it might affect your system in a harmful way. Then we have denial of service. Now this is something we're going to be discussing here today. It's essentially when you attack a system in such a way that it is rendered useless for other consumers or users of that system. So essentially denying them service, right? And then there's the man in the middle. Now, man in the middle is somebody sends a message to somebody, right? And it is an a encrypted format, or it may be non-encrypted as well, which is not recommended, by the way. So the man in the middle will basically take that message in between the path that it is traveling from the sender to the recipient, understands the meaning of that message, and then sends it or lets it go to the recipient. So basically, it was meant for only the recipient. The man in the middle got access to the confidentiality in that message. So these are the most common hacks that are prominent today, right? So we're going to be going over some of these in our tutorial as well. So there are phases involved in ethical hacking. So obviously anything has a process, right? So there are processes involved in a complex hacking sort of routine. So if the ethical hacker is trying to properly hack into a system, not just ethical hacker, any hacker essentially, he has to go through a method, right? But it is entirely recommended for an ethical hacker because he has to go through these methods to find out if any security vulnerabilities are in the system. So he has to follow all of these steps before he actually, generates a report or sends the details back to his employer. So firstly, there is a reconnaissance. Reconnaissance is exactly what it seems to be. It is also called as footprinting. This phase is dedicated to collecting information about the target, right? So this could be information pertaining to the people who are the target, could be information pertaining to the host system, which is the target system, or it could be information pertaining to the network where the systems or the people are running their computers, right? So gathering information as to the specifics of these particular things, like all of the details, all of the complex details that could be basically used to guess their passwords or used to guess their credentials, is called a reconnaissance. To basically understand what you're trying to hack into, basically understand the entire layout of the situation. And then you have scanning. Now, scanning is the phase where you scan the entry ports, that the vulnerable ports, basically the application ports that you can basically get your hands on and get into the system, get into the target, vulnerabilities of the target, or the topology topology of the target net. So you also need to understand how the network actually looks like, where the switches are, where the routers are, what kind of subnetting does the network follow. So to understand all of that, to basically understand what you have to hack and what would your route be, you need to perform this scanning phase, and then you have gaining access. So once you've mapped it all out, so once you've understood how reconnaissance works and scanning works, once you've got the entire layout of the situation, you know what is vulnerable, you know the information pertaining to the target, then you can begin with your actual hack. Now this is an active phase of hacking, which is gaining access into the target system or net, right? So this is what it actually is, the actual step of breaking into a system or network. And then once you have basically accessed the system, once you have gained your access, then you have to maintain this access, right? So your hack might be a long hack, right? And if there is a security patch on the end of the target, if the target basically patches his system and then you lose access, there's no point of gaining access in the first place. So the next step that the hacker would do is install a backdoor onto the system, which is basically a point of re-entry. So even if the target system is patched up or updated, you still have the privileges to access that system because you've installed this little backdoor script or backdoor tool onto the target system. So you have permanent access to that system essentially until you get caught or somebody actually sees the backdoor in operation. And then finally, once you have finished your hack, it is essentially important for any hacker to avoid security liabilities. So the last step would be to clear the tracks of how you were able to hack. So it is also the job of an ethical hacker to ensure if he can successfully clear his track, right? So the job of the ethical hacker is also to basically ensure that if he is able to clear his tracks, he should basically write that down in his report that he was able to do it via this means, and then the security team can essentially ensure that an actual attacker cannot get away with that. So that is what clearing track is, wiping any traces of your intrusion or hack from the target. So these are all of the steps that are involved in hacking and ethical hacking. And these were important to understand because these are the 5 phases of ethical hacking that you're going to be going through a lot if you actually try to opt for this particular domain. So, a quick introduction to CEH, which is the Certified Ethical Hacker Examination and Certification. So, this is one of the most widely accepted certifications for ethical hacking. It is accepted by national security agencies in the United States and a lot of multi-billion-dollar organizations around the world. Right. So, all of these organizations need their security, right? They need their data security and network security. So, all of these organizations prefer people who have this particular certification. Now, who is a certified ethical hacker? A certified ethical hacker who has been officially certified as an ethical hacker after passing the CAH certification exam by the EC Council. Now, the EC Council is a widely renowned council for their certifications. So, if you're able to basically qualify for this particular exam, you have a high weightage in job interviews for this particular job role. So, the International Council of Electronic Commerce Consultants is the full form of the EC Council. It is a professional organization that certifies individuals in various e-business and information security skills. And that is exactly what we are talking about today, information security. So, with regards to that, the position is of a ethical hacker, but the minimum qualifications that you would need in order to attempt this exam, so the option one to attempt the CEH exam would be with training. So, with training would basically mean that you have to go through an accredited training center by the EC Council to basically prepare for this training. So, once you have prepared for that training, you can essentially attempt the official CEH exam. Now, Intellipaat is a partner with the EC Council. We're going to be going over more of that when we go to the tutorial section, but that is your first option. You actually go through one training of some place which is EC Council certified to basically attempt your CEH examination. The second option is without training. Now, without training would mean that you would need to have a minimum of 2 years of work experience in the information security domain, and this particular experience should be certifiable. So, you should have a proof that you have actually worked 2 years in the information security domain. That also makes you eligible for the CEH exam, right? So these are the two ways you can go about that. So what are the job roles that you can get after you've successfully completed your examination? You've passed it. So the first is the most basic one, the most common one actually, which is the cybersecurity analyst. This is also called the information security analyst. The job of this particular person is to basically list down all of the security flaws and basically have an entire view of the security architecture of an organization, particularly the organization that he is working for. That is the job of the cybersecurity analyst to analyze all of those things. The second is more of a developmental sort of role. Now, what that means is essentially a security engineer's part in an application development life cycle is to ensure that the application is following some secure security protocols, basically in the development phase itself. So once the application is deployed, there is no privacy breach. There is nobody who's able to hack into the server or hack into the data, basically all of that. So, for instance, the job of the security engineer would be to ensure that the application is not susceptible to SQL injection attacks. So that is one of the things. And then finally, there is the penetration tester. Now, this is the exact job of an ethical hacker. Now, the only job that this particular person has is to hack into his own employer's system and generate a report for that. He doesn't have to concern himself with any of the security attributes. The only job that this particular person has is to hack into the system and find out all of the security exploits and flaws. So that is the job of the penetration tester. What is the average income of a certified ethical hacker? So this is the average, keep in mind. So in the United States, it's $75,000 US. India, it's about 7 lakhs per annum, and in the UK, it's about 46,000 pounds. Now, keep in mind that this is not the starting or the end salary of a certified ethical hacker. This is the average. So, this is the ballpark of what you will get if you're actually proficient at your domain. And the sky is the limit if you actually get more proficient and learn newer skills in ethical hacking, more advanced skills, right? So, this is the average income for all of that. So, let us go to the hacking tutorial configuration that I am going to be using today for this ethical hacking full course, right? So what I'm going to be using today are essentially, what is it, 5, 6 virtual machines in conjunction in essentially at times, which is what I'm going to be using today for my tutorials, right? So it's Windows 10, Server 2019, Server 2016, Parrot Security, Android, and occasionally Kali Linux as well. So these upcoming tutorials have been executed on virtual machines. Now keep in mind, Parrot Security and Kali Linux are essentially the same thing, right? They are different operating systems, definitely, but they basically achieve the same thing when it comes to security domain, the information security domain. So, what I'm going to be using today, because I cannot obviously run all of these virtual machines together simultaneously, because my computer does not have those many resources. I only have 4 gigabytes of RAM, and to run all of these things together would mean that I would have to have a lot of computer resources. So I'm not going to be running them locally. So if you opt for a accredited training, essentially, if you opt for an accredited training for the CH certification exam, you get access to the EC Council iLabs, right? So I'm going to be explaining to you how that works in a bit. So since Intellipaat has partnered up with the EC Council, if you opt for the accredited training for the CEH certification exam at Intellipaat, you get access to iLabs, which is a cloud platform where you get all of these virtual machines already running without you having to actually run them on your own system, right? So this is basically what that is. You can complete your lab exercises and essentially practice on these cloud systems. So let's talk about iLabs for a second. iLabs is this really convenient utility that basically the EC Council provides to you as part of the package if you decide to opt for Intellipaat's CEH certification training. Now, instead of running all of these virtual machines that I talked about a little bit earlier on, like Windows Server 2019, Windows 10, Windows 2016, and your Linux and Android virtual machines all at once, it is really infeasible for any normal user grade computer to run all of those virtual machines together. So, what the EC Council provides to you is all of these virtual machines on cloud running simultaneously. So the advantage that you get with that is incredibly fast performance, and you can do all of your practice on this cloud environment, complete all of your practicals. So these are the practicals that would be part of the CEH V11 course. So these are all of the modules that you're going to be doing. These include a plethora of tools in a plethora of ways in which you can penetration test and test the security vulnerabilities and hack into the systems to basically complete your course in ethical hacking. So I'll just show one of these particular implements by launching them and showing you how that works. So if I launch one of these, you can see that it checks the browser capabilities and just starts up all of the cloud virtual machines. It says it will be ready in about 1 minute 30 seconds. So let's wait. So after it opens up, this is what you sort of get, right? So you can see on the top, I have Windows 10 selected currently. If I click on that, you can see that there are other operating systems available as well. So all of these operating systems are currently running, currently active, and then you can experiment with all of these in a sort of environment, in a network environment, because you can find all of these. You can ping one operating system device from another operating system device. So that is the advantage that you get. So you can test all of your hacking implements, right? So this is the advantage of iLabs. So the most of these tutorials that I'm going to be doing today is going to be performed on iLabs, except some. But most of these have been feasible only because I have been using iLabs and I have a 4 GB computer. So first tutorial, footprinting with netcraft. We discussed earlier on that the first phase is footprinting. So let us understand one of the tools that helps us achieve that. So netcraft is a provider of cybersecurity disruption services across a range of industries. The company provides web server and web hosting market share analysis, including web server and operating system detection. Now, keep the last line in mind because I'm going to be showing you exactly how that works. So essentially, netcraft is a service, right? So you can either opt for the premium applications of the service to protect your organization against cybercrime, right? The second way is to actually use this particular website to understand how vulnerable is your website, right? So if you type in a website name in the little utility that netcraft gives you, if you go to netcraft.com and type in a little name, right, for the website that you're trying to basically get the information out of, footprint that website essentially. So if you type the website name, you'll get all of the servers that are basically operating for that website. You can get all of the subdomains of that website and the parent organization of that website, the owner of that particular domain. So to basically track all of those things down, you can essentially enter the website name and the netcraft.com web browser. That is the utility of this. Now, this helps because you can get some personal information out of it. You can understand the location of the servers, and all throughout, you can get a layout. You can get a layout of how this entire organization is operating and how the web application is working. So, when you actually try to plan out your hack, you can keep all of those things in mind and then accordingly implement or script or basically go on with your hack. And the key draw factor of Netcraft is you can gauge the operating systems which are essentially running on the servers, right? So the website is hosted on servers and you can understand which operating systems are running on those particular servers. So Netcraft is a pretty interesting tool. It is used for the purpose of footprinting and reconnaissance. So to simply open Netcraft, you can type Netcraft on Google or you can simply type in netcraft.com in your URL bar. Once you've reached the website, it'll look something like this. Now, if you want to find out information with regards to websites that you aim to hack, or to simply just find out details about a particular organization, like for instance, if I simply open up the Facebook URL in this search bar over here at the bottom, so we can see what's that site running. So if you simply scroll down to the bottom of the Netcraft web page, you'll see this. And once you click on this little arrow icon over here, it'll first scan the details for this particular URL, which is facebook.com. So we can see some details with regards to that over here. So we can see that it gives us the website description, which means that we can create or log into our Facebook account if we go to this particular website, right? We can see the website that we've entered. We can see the owner of this particular website. We can see that it's Facebook Incorporated. The hosting company is Facebook, so it's registered officially. The hosting country is the United States, obviously. We can see the IP address. There are a lot of other network related details as well. We can see the IPv6 address as well. We can see the domain is facebook.com. All right. The one of the other interesting things is that we can also see the address for the Facebook offices, we can see that it's given over here, because every organization that needs to basically buy a domain would need to give some details, right? So this is a pretty interesting way to find out details, although this information is available publicly as well. But we can understand that if we were dealing with websites where the information was not available as easily, we can simply use this tool called netcraft, right? So this is one of the basic tools. There's also one very interesting thing that we can do if we simply click on this netblock owner over here, right? That'll open up, and we can see other domains, other websites that are registered under this particular netblock, right? So we have internet.org. So if you're from India, you must be familiar with this particular website, right? Which was an initiative by Facebook. We can see that if we simply type fb.com on Facebook, it'll redirect us to the Facebook login page. That is also registered under Facebook. Oculus is a virtual reality technology that is also owned by Facebook. So a lot of these websites are owned by Facebook. Basically, we can see WhatsApp, and if I simply go to the next page, we can also see that there's Instagram as well. So these companies are owned by Facebook today. So we can see all of it is there, free basics as well, right? And we can also see that the operating system on which these websites are hosted is Linux based. So that is also a very handy detail, right? We can also see the website report. If I simply open that up, we can see the site ranking. We can see a lot of other details as well with regards to that particular domain. We can also see web server related information of this particular website. So we can see that the backend is on PHP, XML, and we can see the encryption tool is the SSL. We can also see that over here, the cryptographic protocol providing communication security over the internet. And we can also see some popular websites other than Facebook that are using this technology. That means PHP. We can see what is being used on the client side. So in the case of Facebook, on the client side, JavaScript obviously is used. So we can see all of that information as well. So let us get to the hacking tutorial of nmap and understand what nmap is in the first place. So this is a topic that comes under the reconnaissance phase of hacking, where you're essentially trying to find out the flaws or entry points that you have in your particular target system. So what is nmap in the first place? Nmap is an open source and free utility for discovering network elements and security auditing, compatible with all of the major operating systems. So this is not limited to Linux. You can also install nmap on Windows and Mac OS. I'm going to be using Kali Linux, where nmap is already installed, and I would advise you to do the same. So it'll scan all of these things. It is used as a security auditing tool as well, not just for hacking into a system. So what is nmap used for? Nmap has many uses. It is used by network and system administrators and network security professionals for various purposes. So it's used for network inventory to understand what elements are there in your particular network, to understand the topology of the network. It is used for that, and to understand if any unknown devices are present within your network as well. So that comes under intrusion detection. So when you're doing the network inventory, if you see something that is unknown, so that is definitely an intruder. Or you can or do host monitoring with it. You can see what all services are running on the host system or the systems that are available on the network. You have service upgrade scheduling. So you can also see the versions of the services that are running on these host systems. So you can upgrade your services according to that and schedule them. And you have your service uptime. Now this alludes to how long have the services been running. You can also keep track of that as well. So what is the workflow of nmap? So nmap works in the simple request response basis. So nmap sends out raw IP packets across a network to perform host discovery and get host related information like the services that the host is offering, the host's operating system, and a dozen more characteristics. So IP packets are sent out to all of the hosts that are available in the IP range in your network. And then after the IP packets are received by these hosts, they will send responses back, and that in turn will tell you all of the services that are available on these host systems. and you can then plan your hack or your security analysis accordingly. So let us now get to the hands-on section. So what we have here are two Linux-based operating systems running within a virtual network that I have created. So currently I have a Windows system, and on top of the Windows system, I'm using virtual machine or VMwares to basically create these two Linux instances. So as we can see, the first instance is a Kali instance. So this is Kali Linux, and nmap is pre-installed on Kali Linux, so we don't have to worry about installing it or anything. And on the second Linux instance, we can see that we have our metasploitable tool Linux. So this is the system that we are going to be hacking, right? So firstly, let us get some background information first before we actually start using nmap. So let us see the IP of the metasploitable Linux. So I'll simply type in ifconfig and press enter. So we can see the IP address within this virtual network of this metasploitable tool Linux is 192.168.160. So I'll just show you guys. If you simply see over here, you can see the IP, that is that 192.168.160. So that is the IP address of our metasploitable tool Linux instance. So let's first run the most basic command that nmap provides to you. So let us just simply type in nmap and the IP address of the target system. So 192.168.1.60, and I'll press enter. So it will start a scan, and it will basically tell me whatever TCP ports are open on my target system and what services are those particular ports corresponding to. So as we can see, we have our scan report for our IP address, which is 192.168.160, which is of the target system. And we can see all of the ports that are open with all of the services that the ports are corresponding to. See now, if you want a really verbose output, as in output in much detail, as opposed to the one that we just got, you can simply add in a switch in your command. So if I simply type in clear the screen up, bring up the previous statement again, and just simply add a -v over here. It will give us the output in much detail, and I press enter. Then we can see that there are much more details associated to our output. So we're getting essentially the same thing with all of the ports which are open being informed to us. It also mentions the IP address where the ports are available, right? And on the bottom, we can see there are some other details available as well, which was the previous form of output that we got. So we can see how convenient it can get when we are using nmap to basically map out the entire configuration and all of the services that are open on the target system. So let us do something new now. Alongside finding all of the open ports in our target system, let us also find the operating system of our target system. So for that, simply type in nmap, give in the O switch. So I'll type in sudo before that, give in the O switch. And after you've given in the O switch, give the V switch again to get our normal information. And then give in the IP address 192.168.1.60. Press enter. So let us see now. We also have gotten the information about the Linux system that we are trying to get into. So if I simply scroll up, we'll look from the above. So firstly, we have all of the open ports that are available on the target system, right? We have our SIM scan for that. And next, we've initiated our OS detection as well. So once we've initiated that, the services are again shown, all of the open ports. We get the MAC address available for that particular target system. And then we can also see the Linux that is running on our target system as well, which is Linux 2.6.9. We can see that raw data packets were sent, raw IP packets were sent to our target system as a request, and we got a response back as well. So this is quite a good tool for network monitoring for an administrator or for penetration testing to essentially see the topology of our particular target network. We also have the option to get more details about the services that are running. So if I simply bring the previous statement back up again and given another switch, which is the SV switch, we'll also get the versions and the exact name of the services that are running on our target system. So if I press enter, it'll scan for it and then we'll get our output. Now we can see all of the exact services running on our Metasploitable Linux. So we can see that the services which are corresponding to FTP, SSH have their versions and names. So this could be useful when you're penetration testing and you're actually trying to find out which particular versions of these softwares or services are running on your target system essentially. So you can manipulate your hack according to that. This also is useful to understand if there are any processes that are not supposed to be running on your target system as well. So by looking at this, we can get that information. There are also options for you to get some details as well. Instead of getting these extensive details, we can also limit our output to a certain quantity. So for that, we'll simply type in firstly, just clear the screen up and simply type in sudo nmap. And let us just simply use a ping command, the nmaps version of ping command. So we'll basically send a raw data packet and get a response back with the basic information about our target host. Type in -s, capital P, and then given the address, which is 192.168.1.60, and press enter. Now we can see the MAC address associated to that target ping. So we have our MAC address. So there may also be times where you don't exactly know the IP address of the target system, or you just simply want to find out what devices are available in the network that you're operating within. So for that, you simply bring up the previous statement again, which is the ping statement, and just remove the last part. Depending on the network subnet that you have, you can simply put in an asterisk and press an enter, and you'll get all of the IP addresses present within the 192.168.1 range that are available within your network at once. So right now, I only have two IP addresses within that range. So the first IP address is my IP address, which is 192.168.1.50 of the Kali Linux operating systems device that we have right now, which is the host device. And the second one is the target system, which is 1.60. So that has also been scanned from our ping scan right now. So what if there's a case where you want to find out what services are running on port 80 in all of the systems that are present within your network range? So for that, you can simply type in sudo nmap, given the option of -p80. So this will only scan the 80 port in all of the target systems. And then you can simply give in your IP range, which is 192.168.1. And when I press enter, it will give me what is available on port 80 on all of the systems in your network within this particular IP range. So as we can see for the IP address 192.168.160, we can see the HTTP service is open on port 80 on our target system. And for us as well on the host system, we also have the service of HTTP that is open. So port 80 is generally assigned to HTTP. So that is not a surprise. So we can understand from that this is working the way it is supposed to work. So let us look at another case where you have multiple ports that you want to scan. So for that, simply put in a comma after 80. So say if you want to scan the port 24, if you want to scan the port 28, 80, 80, 12, and simply press an enter after that. So this will basically scan all of the ports that I just mentioned. So we can see that the 24th port is closed, and it is basically reserved for private mail. And we can see that the 8080 is for the HTTP proxy, and our 80 again is for the HTTP. So you can use all of these tools to understand the complexities of the target network that you're dealing with, or the target host that you're dealing with. And it can essentially tell you the vulnerabilities as well of the target system when you're running these commands. It is also a great tool for network administration because you can understand if any unknown device has entered your network. You can also understand what kind of services are running on that unknown device. So you can see that it is a very handy tool when we are dealing with hackers and attackers as such. Network enumeration with netbios. Now, enumeration means counting or listing out. So, one of the utilities that you can use to enumerate all of the hosts that are present on a particular network is netbios, and it is an acronym for Network Basic Input Output System. It provides services related to the session layer of the OSI model, allowing applications on separate computers to communicate over a local area network. So, what the NetBIOS essentially does is you can type in a IP address in your particular network of a host, and it will give you information pertaining to that IP address, maybe the MAC address, right? And if you scan within a range, right, you can get all of the hosts that are present within that IP range in your net, right? So NetBIOS enumerator is a UI tool that you can use for that. You can enter the from IP address and the to IP address, and within that particular range, it will give you all of the IP addresses that are allocated to hosts. Right. So the NetBIOS enumerator is a tool used to list all of the hosts present on a particular network within a specified IP range, also giving certain information pertaining to the host's configuration, which include the username of that host. Say you log into your Windows computer, you enter a username. There's a username, and you enter the password for that. So it will give that information. The domain that your particular computer is registered to, the MAC, and the latency. So the MAC address and the latency, which means how long it takes for the target system to respond once the attacker system sends in the request, the ping essentially, so the latency. So let us understand how this works. So let us now understand how we can use the tool NetBIOS to perform network enumeration. So say you have multiple devices present on your network. How would you find out the information with regards to them? So simply open up your command prompt with administrative privileges if you're dealing with Windows computers, and then simply go to the terminal and type in nbt stat and given a hyphen a. This is the option which I'll explain later. And then type in the IP address of the target system that you're trying to hack, which is 10.10.10.12. This might be different in your case. And when you press enter, it'll basically enumerate certain information about the target system. And as we can see, the particular option A, when we put it in with the IP address of the target system, it gives us the name of the target system, which in our case is server 2012, and it gives us the MAC address of the target system. Now, assuming the target system is not MAC spoofing, which means it's not giving us a fake MAC address, this is the actual MAC address of the target system. So this could help us further identify the technology that is being used in the target system itself. Now, the other thing that you can do with it, in the case that you do not know the IP address of the target system, you can simply scope your network out by typing nbtstat-c and you press enter, and it will give you all of the hosts that are present on your target network. And in this case, we can see that the server 2012 is available on our target network, and we can see the IP address that it has, right? So we can also scope out the IP address of the target system. Now, the second step that we can do afterward is simply type in nbt stat and hyphen a, and given the IP address itself, and you press enter, then you can get further details about that particular host. There's another tool called the NetBIOS enumerator. In this, you can specify an IP range. For instance, if I specify something like 10.10.10.11 to 10.10.10.16. It will give me all the possible hosts that are available on this particular IP range if I simply go ahead and click on scan. So as we can see, one result has come up, which is the server 2012, which we saw earlier on in our command as well. So if I simply expand this, I can see a certain amount of detail available for this particular IP, right? So this IP has been found between this particular IP range, right, on this network. Then we can see certain information with regards to that. The username, which is no one is logged onto the system currently. The domain on which that particular system is, which is the CEH domain. And as the name suggests, this is useful in enumerating the network, finding out all of the hosts that are present on the target network. Vulnerability analysis with Nessus. Now, Nessus is a tool. You can opt for the premium Nessus services, which is Nessus Professional, or you can go for the free version. You obviously get a lot less features in the free version, but it is a tool that you can essentially use to scan a particular network, right? So what does Nessus essentially scan? So you can see there's a really beautiful UI that Nessus has, and you can see all of the problems that are critical are listed in the first priority, and then you have medium range problems and high range problems as we go down. So it is a very essential tool for a security analyst to basically understand what sort of exploits are present in the network and in the hosts, and to basically look at the critical problems and resolve them as soon as possible before the black hat hacker or the hacker with the malicious intent can basically start an attack and get access to that system or cause harm to the organization. So Nessus is a very important tool for that. It runs a variety of scans to get that information. So what exactly does Nessus help patch and secure? So first thing that it does is it tells you the vulnerabilities that allow unauthorized control access over sensitive data. So any threat, any exploit that can be used to get access to sensitive data, misconfigurations that leave systems exposed. So sometimes some particular individuals in departments could misconfigure their softwares or utilities that could leave an opening for an attacker to get into the system, right? So it is the job of Nessus to detect those things, and the job of the security professional to patch those things up. And second, finally, to detect default passwords. So oftentimes, a lot of people, what they do, if they are operating within a domain, a network, they don't configure tough passwords. They let the default passwords be. So the default password could be something like password itself. So those are not essentially good practices. So if there is a loophole like that, Nessus will detect that, and then Nessus will obviously inform that to the security professional as a critical problem that exists within the domain, and then the security professional could ask that particular individual to change his password or change it himself manually. So that is one thing that Nessus does. And then there are DOS vulnerabilities, which is denial of service vulnerabilities. So any opening, any entry point that may make the network or system susceptible to denial of service attacks, Nessus also lets you know about that. So these are the properties of Nessus. Let us understand how this works in practice. With tools like Nessus Essentials, you get your core pack of vulnerability analysis utilities. So it provides you with a simple user interface where you can simply go to My Scans, which you can see very conveniently represented visually, and then click on Create a New Scan, right? Now this gives you a plethora of new options, right? So you can select from any of these. So firstly, if we want to simply calculate all of the vulnerabilities in the system, we can specifically provide an IP range. If we do a basic network scan, we can simply name this scan 1. We can call this a vulnerability scan, and we need to provide the target IPs, right? So in our case, let us provide 10.10.2, 10.10.10.16, right? So within this IP range, which is 10.10.10.10 to 10.10.10.16, it will basically find all of the basic vulnerabilities. So if I simply click on save, right, and if I simply select this and click on launch, the scan will begin. So we can see that the scan is currently running. After it has finished running, we'll see that icon over here. We can also go ahead and simply check the current prognosis. So we can see that we have found a certain bunch of vulnerabilities. So if I simply click on vulnerabilities, we can see that there are a lot of details that are available. We can see the nessus SNMP so scanner, DC services emulation. If I simply open up some of this, we can see that the vulnerabilities that are involved are very detailed, and this could really help a hacker who has successfully infiltrated inside a network basically find all of these things out. And all of this information also is very beneficial to any security official whose job is to basically audit the security of their employer's network or the security of the network that they are trying to secure. We can also see a very critical analysis of the entire exploits and vulnerabilities present inside the system, because it also provides us with pie charts of the sort where we can see that there are about 81% non-threatening vulnerabilities. There's about 4% high vulnerabilities and 15% medium. And based off of all of these details, the hacker can simply plot a very well detailed hacking plan as to how he would go about infiltrating the system. System hacking with lophtcrack. Now, as the name suggests, we are going to be cracking something with this, right? So, passwords. There are passwords associated to all of the hosts that are present on a particular network. So, in order to get into those operating system accounts, you need to have passwords, and lophtcrack is one such tool that does exactly that. Lophtcrack is a password auditing and recovery application originally produced by Mudge from Loft Heavy Industries. So that is the organization. It is used to test password strength and sometimes to recover lost Microsoft Windows passwords by using dictionary, brute force, hybrid, and rainbow tables. Right. So these are the various methodologies by which password cracking can happen. It is originally meant for good because it is used as a tool by the security expert to understand how strong passwords are in the domain. So if somebody writes something like password as his password, this will immediately detect that and this will inform, and then you can essentially let the person know to change the password. But yeah, it also helps with recovering lost passwords because this is the tool for that. It uses a lot of methods to understand that. So dictionary method is one where there's a word list essentially, and the brute force attack will go through that word list and try various combinations of those words to guess the password. Then there's brute force, which means the system or the tool will essentially try combinations of all characters specified for that particular brute force attacks. So it's basically a permutation and combination attack where all of the possible combinations of those characters will be tried. So that is brute force. Then there's hybrid attacks, which is the combination of dictionary and brute force, where a lot of dictionary words can be jumbled up together to try those particular attacks. And then there's rainbow tables. So what does it do? Lophtcrack retrieves the hash of a particular system logon. So there's hash files that are generated. What are hash files? Whenever you enter a password, the password is not entered into systems as plain text. So they are not entered into systems as what they are. They are first converted into hashes, and then the hashes are matched with the databases present on the target system. When they are matched, when there's a successful match, then only you get your login. So this is a method to basically ensure that no particular system has the actual passwords stored. So even if somebody hacks into the database of that system, the hacker cannot simply enter the password out of that database and get access. He has to enter the correct password, which will then be algorithmically encrypted into the hash, and then it will be matched with the one present in the database, and then you'll get your login. So that is what hashing is. So it retrieves the actual hashed password. Then, based on the hash password, it converts a combination of plain text and encrypts them into that hash, matches it with that, and then you finally get your right password when the combination actually matches. So let us understand how this works as a tool. So let us implement lophtcrack version 7. So it's a pretty simple tool to use, but we can obviously implement more complexities with it. So all of those complexities would be discovered if you opt to dwell further into this particular topic. So for now, let us find out the passwords of the devices that are present on my network, right? So how to go about that? So lophtcrack gives you a simple utility which is called the password auditing wizard. This is basically used to assess the security of the passwords that your systems have, right? Because if the hacker gets access to the administrative computers, that could be really messy for the entire business, right? So you don't want that to happen. So you want to assess the security of the passwords on all of your devices. So I'll simply click on next. And then there are two options that I get. So one is for Linux and one is for Windows. So let us focus our hack currently on Windows systems. So we'll simply click Windows. We'll retrieve the password hashes from our Windows systems, and then I'll simply get a password hash. Now I can simply have a password dump from another tool such as this, a password auditing tool for that matter, or I can simply use my own credentials, my own hashes from my own Windows system. So for that, I'll simply click on the local machine. So I'll make sure I have administrative privileges so that I can actually use that. And once I have that option selected, I'll click on next. And then I'll simply use the use logged in user credentials instead of using specific user credentials, because I am currently an administrator on the system, so I don't need specific user credentials. And then I have various options available to me with regards to what sort of hack I want to perform, what sort of audit I want to perform. So what these audits are essentially going to do is that they're going to run a series of brute force methods and dictionary methods to guess the password based on the hash. And there are various options for that. Like we can apply for the strong password audit. So this is a very taxing audit. It takes about 24 hours to completely finish, right? Because it tries a various number of combinations basically to guess your password. Then there's the thorough password audit, right? It could take up to 6 hours, and then you have the 1 hour common password audit. So let us go with the 1 hour one and simply click on next, right? And I also have the option of generating a report of my auditing at the end. So if I can simply click on CSV format, and I'll get my report in CSV format in this particular location. I can simply specify that as well, right? And then I'll simply click on next. So once I click on next, it will basically give me the option to select when I want to run this particular audit. So I'll simply click on run this job immediately. And once I have that selected, I'll click on next. So it'll give me all of the options to basically verify if I want to go with this. So you can check this, cross verify it, and then you can simply click on finish. So it will basically ask me for administrative privileges. So I'll click on yes, and it'll basically start running onto my network. So we can see that three accounts on my network were without a password. So they were instantly cracked because they didn't have a password. And as we can see furthermore, other accounts are getting guessed. So the account which was Martin had the password Apple, so that was guessed. So this was a pretty simple password, so it was guessed rather quickly. But basically, what happens is the password is in plain text format. The password in plain text format runs through an algorithm which converts it into a hash code, right? So this is the hash code that you can see over here. So it basically takes a random bunch of words, tries dictionary words, and tries to convert it into the hash format. And if the hash matches with the existing hash on the target system, it basically tells us that the password hack has been successful. You've successfully cracked the password. So some particular hacks can take more than other hacks, and it basically depends on the complexity of the password. You also get a lot of options with this particular software, which is Lophtcrack. So you can use custom repositories of dictionary words that you have that you may think might be compatible with the systems that you're trying to hack. They might be the passwords of the systems that you're trying to hack, right? And you can get your hashes from elsewhere as well. So if you're trying to hack into a system and it has localized hashes, you can get it from there, and you can simply get a speed boost in your hacking attempts. ARP poisoning with cain and abel. Now, cain and abel is a tool which is used for primarily password recovery, but that is not what we are going to be using it for today. It can recover, though, many kinds of passwords using methods such as network packet sniffing, which is something relevant to today's tutorial, cracking various passwords, hashes by using methods such as dictionary. So similar to what we discussed earlier on. So what is ARP poisoning? So ARP is a short form for address resolution protocols. Right. So in ARP spoofing or poisoning, or ARP cache poisoning is a technique which the attacker uses to spoof address resolution protocols, right? And messages which are basically sent on local area networks. So he can modify those messages. He can essentially alter those messages. So it is the job of wireshark, which we can use optionally to detect these sort of things. So in a particular network, if you have an administrative PC for that particular network, you can detect all of the network activity happening with Wireshark. So Wireshark is a free and open source packet analyzer. It is used for network development, troubleshooting, analysis, and software and communications protocol development and education. So Wireshark is also used to basically understand how all of these hacks work, because you can see network activity that is happening. So for ARP spoofing attempts or ARP poisoning attempts, you can see those things exactly as they happen when they are happening in this particular log that is appearing on your Wireshark terminal. So Wireshark helps detect packets with suspicious origins or intent. So any packets which are suspicious, which means the corrupted or poisoned ARP packets, you can detect that with your Wireshark. So we'll see how that happens in a bit. So to implement sniffing, we will be using a tool called cain. So we'll open that up. Once we open that up, we'll simply click on configure. After we've clicked on configure, we'll click on sniffer, right? And we'll select the device, the adapter that we're currently using. After we've selected the adapter, we'll click on OK. Once we've clicked on OK, we'll click on the sniffer icon that we have, which is the start stop sniffer. Once we click on that, a warning will come. I'll simply ignore that. Then we'll click on the sniffer icon over here to see the current status. The next step is to detect all of the devices that are present within the specified IP range. So for that, we'll click on the plus icon, right? And here we can specify the range. So in my case, I will specify 10.10.10.1 to 10.10.10.30, and I'll click on all tests, right? Because we want to test for every sort of ARP, and click on OK. So we get the list of all of the devices that are present in our subnet within that IP range. Now, to detect communication between two hosts that are present in this IP range, we need to specify the to and fro IP, right? So firstly, we'll click on APR, and then we'll click on this particular area and click on the plus icon, right? Now we can specify to and fro. So firstly, let me select 10.10.10.10 to 10.10.10.13, right? These are the two that I'm going to be selecting, and I'll click on OK. So as we can see here, we have our to IP address over here, and we have our fro IP address over here. Now, the next step would be to actually simulate some packet sending. Now, the next step would be to simulate communication between these two hosts. So let us do that. So firstly, I'll switch over to my Parrot security. This is a Linux-based operating system. Firstly, I'll open up the terminal. So after switching to the root, let us type the hping command to send some packets to our Windows 10 PC. So we'll type hping 3 10.10.10.10. So this is the IP of the Windows 10 computer. And then we'll give the packet count of about 100,000. And then we'll press enter. So this will begin our ping. So firstly, I'll open up Wireshark to detect this network traffic, right? And after I've opened that up, I'll go to edit and preferences. So the first thing that I'll do is go to protocols, expand it, and simply scroll down to ARP. We get this option, and then we'll simply click on the tick icon on detect ARP request storms. Once we've done that, we'll select our Ethernet adapter. Now we will start poisoning our packets. So we'll click on start stop APR. Right now the poisoning is active. So we can see that the status of the packets are being poisoned currently. And if we switch back to Wireshark, we can see very well what is currently happening. We can see that between these particular IPs, the source being .13 and the destination being .10, the packets are currently being intercepted and poisoned. Now what we can do is stop this detection process with the help of Wireshark, right? And we can go to analyze and click on expert information, right? So we can clearly see that over here there is a warning which says that duplicate IP addresses have been detected, which are mapped to 10.10.10.10. So what has essentially happened currently is if I switch back to cain enable, we have replicated that particular IP, which was the Windows 10 IP address 10.10.10.10, and we have assumed that IP address to receive those packets instead of the actual Windows 10 device. So we are basically sniffing those packets that are being sent by the Linux system to that Windows 10 system. So what the Wireshark has done, it has successfully managed to detect that there's a duplicate IP because there are two different MAC addresses attached to the same IP address. So this is essentially how you would detect packet sniffing if you're a security professional with the help of Wireshark. Phishing with social engineering toolkit. Now, this is one of the most popular attacks that happen around the world. It still happens today, but it is very easy to spot these things, right? You can see the IP address of these websites and you can easily spot these things. So, what is phishing with SE toolkit? So, the social engineering toolkit, first of all, is an open source penetration testing framework designed for social engineering. SET has a number of custom attack vectors that allow you to make a believable attack really quickly, right? So it is a tool that you can download on your Linux systems, and you can initiate these attacks with this particular tool. So a lot of attacks you can do with that: social engineering attacks, penetration testing attacks, third-party modules. Then these are the particular things that you can do with that. There are a lot of integrations with social engineering toolkit as well. So phishing is one of those attacks. This is present in the social engineering attack section of the SE toolkit. Phishing is the process of creating a fake login page resembling an application identical or based on something that the target uses, sending the link to that page to the victim and extracting their login credentials in plain text format. So that means that you create something that looks identical to the Facebook login page, right? And you send something like a facebook.xyz to your victim, to your target. The person opens that link, thinks it's Facebook, enters his username and password in that link. So you're smart enough to redirect him to his actual Facebook page. So he actually logs into his Facebook page. But what the target does not know is that you have successfully gained access to his password and username in plain text format. So if you go ahead and go to the login tab of Facebook and type in those things that you've gained, you will also be able to log into his particular session. That is how phishing works. It's exceptionally harmful if it's happening on your bank account. Although these days there is two-factor authentication to prevent exactly this. So that means even if somebody is able to rightfully guess your password, they still wouldn't get access to your account because they'll get a text on their phone or they'll get an authenticator message on their phone. And until you enter that authenticator message that they've received on their phone, you cannot actually log in. So this is how social engineering toolkit works. So we'll understand how phishing works with an example right now. So let us now understand website phishing through the social engineering toolkit that you get. So firstly, let us start our social engineering toolkit. So simply type in SE toolkit in your Parrot terminal, right? So once you've done that, you'll get a lot of options, and then we'll select social engineering attacks because that is what we're going to be doing. Now we're going to select website attack vectors. And then we're going to select credential harvester attack method, where we are going to harvest the credentials of victims who decide to choose our phishing link. So once we've done that, we'll use site cloner, right? Firstly, we have to give the postback URL for the website that we're going to be cloning. So we're going to use the IP address of this particular host, which is 10.10.10.13. So we will type in the URL that we want to clone. In our case, it's http www.moviescope.com. So it'll take a bit of time to actually clone the website. So let us now try to open that particular link. So http n.10.10.13. So we can see that we've successfully opened up a cloned website now. If you actually hide this IP address behind a link that looks like it leads to the actual website, then you can successfully trick your victim into basically giving up their username and password that they would have normally entered when they were logging into this movie scope website. So let me show you how this works. So say I type in something like admin and I type in something like password and I press login, right? So I clicked on the login button, nothing happened. It could have happened as well if we had actually logged in, but let us see on our Parrot security as to what information we have obtained. So we can see that whatever the victim had written down, like for instance, the username had been admin and the password was password, right? So we got that in plain text format. So we can see how this could be useful for a hacker who's trying to gain access to their victims' bank accounts or social media accounts. Just by simply giving them a dummy link or a phishing link, they could fool that particular user into registering for a fake account and giving up their credentials. So this is how phishing works with the help of the social engineering toolkit. DDoS attacks with h.o.i.c, which is the high orbital ion cannon. Sounds like a pretty fancy name, but this particular thing has been developed by fancy people, which is anonymous, the Hacktivist Collective. So it is a free open source network stress application developed by Anonymous, a hacktivist collective, and used for denial of service attacks. So it's not entirely intended for harm. It's basically used to test the proficiency of a network in handling high traffic. So, what is a denial of service attack? It is essentially an attack where a particular host or a particular server is flooded with requests. So, these particular web applications these days they work on a request response basis. So, the client sends a request to the server sends a response back. It goes on and on. That is how a website works. So in this particular case, what will happen is a lot of like thousands or to millions of requests would be sent to the web server at once. And then obviously the web server will slow down and it will crash at some instances, or it will slow down to the extent that none of the other users are able to use it, right? So that is essentially denying them the service. So that is why it's called denial of service, right? So DDoS, it is exactly that, but at a much higher extent, where you're using these botnets, you're using these bots that are present all around the world. So it is harder to detect a DDoS attack, because in a DDoS attack, what will happen is all of these attacks, all of these requests will be coming from different hosts, right? So it's not entirely easy to identify if they are malicious in intent or not, right? That is what a DDoS attack imitation is, what a high orbital ionic cannon will do. You can simply click on the fire the laser button and it will send a plethora of requests to a particular server at once. And then you can see how well the server deals with that, right? Or if the server is able to sort of subvert that attack. So that is what a denial of service attack is. So let us understand how this works in the tutorial. But before we actually do that, we also need to understand about anti-DDoS Guardian, which is a tool to prevent exactly this. So there are DDoS attacks. So there are tools to prevent those DDoS attacks. So Anti-DDoS Guardian is a high-performance DDoS protection software for Windows servers, specifically the Windows servers that we are going to be using today, the Windows 2019 and 2016 server. It stops most DDoS or DOS attacks, including SYN attacks, IP flood, TCP flood, UDP flood, ICMP flood, slow HTTP DDoS attacks, layer 7 attacks, application attacks, Windows remote desktop brute force password guessing attacks. So a long list of things, but the DDoS Guardian is prepared for this, especially if you subscribe to their premium services as well. But even in non-premium mode, it works exceptionally fine. So Anti-DDoS Guardian monitors the server and keeps a lookout for suspiciously large number of incoming requests and prevents a server overload by mitigating those requests. So say the what the anti what this particular tool will do is it'll establish a baseline of activity for a particular web application. So if the baseline of activity is altered, if somehow there are a lot of requests suddenly, right? So obviously something is wrong. That should not be happening because that is not on the baseline of activity, right? So once that happens, this particular tool will automatically detect that and subvert that attack. So we'll see this in action as well in this particular tutorial. So this is going to be a demonstration with regards to how to initiate and detect a DDoS attack. So in this particular case, what is going to happen is my Windows 10 virtual machine has this tool installed called the Anti-DDoS Guardian 5.0. Right now, this tool is supposed to detect DDoS attacks. So any attack which has a lot of packets coming from one IP in general, this particular Guardian will stop that. So I have it installed and ready to be deployed. So let me switch to the attacker computer. So my attacker computer in this case is going to be a Windows Server 2019, and I already have a high orbit ion cannon in place. Now the name might sound fancy, it's just a replacement name for a DDoS attacker. This particular application will send a lot of packets to the target computer, in this case my Windows 10 virtual machine, at the same time and effectively dismantle the services of that particular Windows 10 computer. So the first thing that I would do is select that particular IP. So I'll click on the plus icon and put in the IP address of the Windows 10 virtual machine. So I've put that in, and then I am going to increase the power of this particular orbital cannon attack to high. So this means instead of a low number of packets, a high number of packets will be sent, which means a higher load. And then I'll select the generic boost h.o.i.c attack, right? And I'll click on add. Just a moment, my IP was a little bit wrong. I'll edit that. So I'll also make sure that I put in the IP in the form of a URL. So HTTP. And after I've done that, put it to high and select the generic boost. Click on add. Now, as we can see, the status of this cannon is ready. I just have to simply click on this red button over here, which is fire the laser. So once I click on that, this particular DDoS attack will start. So let me begin. Right, so the status is engaging. Let me switch back to my Windows 10 PC and look at what is going on in the DDoS Guardian. So if I scroll down, I can see, like, right over here, I can see that there's a lot of activity in outgoing and incoming IP packets, right? So this is obviously an attempt to DDoS this computer, or it might just be suspicious. So we'll check it out. Right. So once we double click on that, we can see that a lot of IP packets are coming in. It's just swarming this computer with IP packets, right? So one simple thing I can do now that as a security specialist, I have detected that a computer or a IP is trying to hack into the system by causing a DDoS attack. I'll simply block this IP. So once I block this IP, we can see that it goes red, and it doesn't matter how many packets are being sent by that particular PC or virtual machine. It does not matter to us because we are simply hard blocking that particular IP. So we can see how with the tools such as anti-DDoS Guardian or any other anti-DDoS tool, we can prevent such attacks. And it is important as well because if we are operating in organizations like Amazon or Facebook, it is very damaging for any of those organizations to have these attacks put on them because it could temporarily suspend their services. Session hijacking with bettercap. Now bettercap is a tool that is used for this particular task, which is called session hijacking. So essentially when you log into your social media accounts or your bank accounts, what happens is these particular websites are generating a session key for you. Now this session key is valid only and only for you because they need to provide you with the privacy because these particular accounts are very sensitive. So bettercap is a tool. If your session is unprotected, bettercap is a tool that can detect all of these things and essentially get access to your session, right? That is called session hijacking. So if your session is unprotected, bettercap can give the attacker access to your username and password. So it is also used as a tool for a lot of engineers, red team users, and researchers. To it is an essentially easy to use all-in-one solution with all of the features that they might possibly need to perform reconnaissance and understanding how susceptible systems are to Wi-Fi network attacks or how their Bluetooth low energy devices are susceptible or wireless HID devices and devices all spread all across the Ethernet networks, right? So if your session is unprotected, bettercap can very easily capture credentials and sensitive information or confidential information from unprotected sessions on a particular network. So if you log into a particular website, bettercap has got it. It'll basically get your user ID and login credentials, and then the attacker has access to that as well. So it is used as an application to test whether these sessions are protected or unprotected. So let us understand how this works in action. So in this particular tutorial, we're going to be doing two things. The first thing that I'm going to do is turn on my wireshark, wait for that to open up, and then I'll select my Ethernet device. So I'll skip this particular thing, remind me later, and then I'll select Ethernet 2, right? So I have begun monitoring Ethernet 2, right? So all of the packets that are being transmitted from one particular device to another in this particular network, I can monitor from this Wireshark outlet. Now, to demonstrate network sniffing in action, we're going to switch back Parrot security. So I'll just log into this. So once I have logged into that, the next thing that I'm going to do is open up the terminal in Parrot Security. And we're going to be using bettercap, obviously, to initiate this network sniffing attack. So firstly, I'm going to switch to the root user in this terminal of Parrot Security. So for that, I'll type in sudo su, and then I'll type in the password, and then I'll go back to the root directory. So now I am in the root directory. Now I can run bettercap. But before we do that, actually, we need to find out the name of the Ethernet device, similar to how we found that out when we were using Wireshark in Windows 10. So I'll type in ifconfig. Right? So in ifconfig, we can see that this particular IP address is our IP address, and this particular Ethernet device name is ETH0 is the name of the Ethernet device that we're going to be using in Parrot security. So let us begin with that. I'm going to clear this up. So now that I know the name, I'm going to type bettercap hyphen iface ETH0, which is the name of the device. And then I'll press enter. Now what we can do is type help, and it will give us all of the possible commands that we have for bettercap. So we want three things on, which is netprobe, netrecon, and netsnif. So we're going to turn them on one by one. Netprobe on, netsnif, no, netrecon on, and netsnif on. So once we do that, it'll start sniffing all of the network activity in the subnetwork, which consists of all of these virtual machines, right? So to see basically what is going on, we'll switch back to Wireshark and see what's going on. So let us switch back. Go to Windows 10 again, right? Now we can see certain activity happening in Wireshark. So we can see the sniffing activity in the works. We can see the recipient is 10.10.10.13, which is the parrot security IP address, which we saw earlier on. And we can see that these particular messages, like who has this particular IP, and all of this information is being sent to 10.10.10.13. So we have successfully detected a particular IP which is sniffing the network. So that is how network sniffing happens, and Wireshark is how we can detect network sniffing. Honeypotting with Honeybot. Now, Honeybot is a tool used for honeypotting. What is honeypotting? We'll get to that. Honeypot is a medium interaction honeypot for Windows. It is a fake device occurrence on our local network. The device works as a target for hackers and to get what they want from a fake data on the device. This is great to learn how the attacker thinks and what his intent is. So essentially, you're creating a trap for the attacker. So the attacker will basically access that trap and might reveal something about how he attacks your system, or might reveal his own personal information as well. Because you're essentially baiting the hacker into hacking into your system by pretending that there is some information that is available, which is fake information, right? So how does it work? A honeypot is a device placed on a computer network specifically designed to capture malicious network traffic. The logging capability of a honeypot is far greater than any other security tool and captures raw packet level data, including the keystrokes and mistakes made by hackers. So essentially baiting the hacker into thinking your system is vulnerable and susceptible. The hacker will do whatever he needs to do and might reveal something about himself or something about the nature of the attack that he's trying to carry out, right? So all of this information is very relevant for security team experts because they can understand how these hacks work. And secondly, to basically track down any person with ill intent, essentially, because any person who commits a mistake and is caught can be caught using a honeypot. So let us understand how this works in practice. So as it can be seen here on my Windows Server 2016 virtual machine, I have my honeypot service currently open, right? So this is being used to monitor any activity that happens. Now, the next thing that I'll do to basically imitate an attack is I'll switch to my Parrot security terminal. So let us open up the terminal and switch to the sudo user. So once I have done that, I'll simply put in an FTP request to 10.10.10.16, which is my Windows Server 2016 virtual machine's IP. When I press enter, it says connected to 10.10.10.16. So if I go back and switch back to my Windows Server 2016 and check back in my honeypot, simply by firstly I'll log into that. So we can see that there's some information available over here. So if I expand ports, right, so I can see this. So the thing that I can do is view details. So when I view details, I can get the details about the attacker that may be trying to get into my system, specifically the file system of my system, because the attacker has initiated a file transfer protocol, the FTP. So we can see those details over here. We can see the packet information over here when I open up the view details section, right? So if I close this up and I expand remotes, we can also see the attacker IP, which is 10.10.10.13, which is the IP of my Parrot security virtual machine, right? So in this way, you can essentially determine which particular system within your own network may be trying to get into your system or your file system. So this is how certain people would evade firewalls and other security measures. And this being a honeypot basically is a trap for those potential attackers to identify themselves. Web server reconnaissance with HTTP recon. Now, HTTP recon or HTTP fingerprinting is a tool developed by Computec and modified by W3DD. These are the authors to help return highly accurate identification of given HTTP implementation. So essentially, you enter the URL of a particular website and the server of that website. This particular tool will return the information of that server. So this is very important within professional vulnerability analysis because you need to ensure that your server's information is not accessible to any outside person. So if you run the HTTP recon tool for your particular web application and some sensitive information with regards to how your server is operating is revealed to the attacker, that is a very risky thing, and you should ensure that whatever means you're implementing in your particular website is subverting those particular risks, right? So that is the entire role of HTTP Recon in the professional security community. It is used by hackers to essentially gain information with regards to how your server is operating. It is used by security professionals to patch those things up, to not basically allow that information to be revealed to the hacker. Let us understand how this works for websites. From footprinting of a particular website, we can also use HTTP Recon. So let us open that. You can open that up without any administrative privileges, but that might cause some issues. So I'll open that up with administrative privileges. So once you've opened that up, I'll expand this a little bit. So in here, you can write the website name that you want to footprint. So in our case, let us type in so www.intellipaat.com, right? So once I've written that, stop, and then I'll click on analyze. So it will take a bit of time, but it will give us all of the footprinting details of this particular website. So we can see right over here on the get existing part, we can see over here there are servers that are mentioned. So there are percentages that are over here. There is a match percentage that we can see. So for this Microsoft IIS 6.0, we can see that it is a 100% match. So what footprinting will do, it will essentially analyze the data from the website and it will try to determine which particular backend server is being used for this website. So the traits for this particular one match 100% with Microsoft IIS, but you can also see there are other matches as well, which are not as accurate as the Microsoft one. You have an AOL server, you have Apache, right? You have Zeus, you have Nginx, so on and so forth. You can see the match percentage is decreasing in descending order. So we have all of this. So right now we don't need to worry about it much because we already have a 100% match. But in the cases where we don't get a 100% match, we have to go on probability. To see all of the get requests, I'll click on get long requests, right? So over here we can see all of the get requests, right? The other thing that I can do is click on fingerprint details. So one of the most important details that we can see over here is that there's a protocol name and there's a protocol version which is 1.1. So hackers can essentially use these details in order to basically maneuver their hacks in accordance with the exploitations that are available for these particular protocol versions. So you can see if you are a hacker with a certain level of knowledge, you can manipulate all of this information to basically help you out in whatever hack you're planning to do. So this is a software utility in order to basically recon a particular website to perform footprinting and reconnaissance. Web application footprinting with whatweb. Now, this is very similar to what we just discussed, except this also gives information with regards to the application itself, not just the server. So, what happens is whatweb recognizes web technologies, including content management systems, blogging platforms, statistical analytics packages, JavaScript libraries, web servers, and embedded services. What happens is, whatweb will scan a website to detail out the category of a web application, the author, and the technologies that are being implemented in that web application. So a website is authored by someone, that will be revealed. What is the password field? What is the login ID field? That will be revealed. So everything on the client side that is visible is revealed. So the HTTP server information, what server it might be using, all of that information, the IP address, the author. So these particular details are there. So even something like what particular organization is powering this particular website, that is also revealed. So that is how whatweb essentially works. So let us see whatweb in action as well. Keep in mind that this is exclusively for web applications. For web servers, it is entirely recommended to go with HTTP Recon. For web applications, the client side of things, you can go for whatweb. So one of the tools that we use when we are trying to actually hack into a web application is whatweb. So let us see the sample website first. The sample website is moviescope.com. So we can see that it is a dummy website, which we are essentially going to get some information out of. So if we go to our Parrot security terminal, and I'll open up a Parrot terminal. So I'll first switch to sudo mode. So for that, I'll simply type in sudo su and enter in the password for my sudo account, right? And then I'll change my directory to the root directory. And afterward, I'll simply type in whatweb, right? So this is a utility that is present in Parrot security, which is used for this exact purpose. When I enter that, it will give me a help, essentially has some help commands as to what the usage format for what web actually is, right? So if you want to actually run this on a particular application, so for instance, on this particular subnet, the website that we previously saw, that was moviescope.com exists, right? It exists on the Windows Server 2019. So if we simply type in whatweb and type in moviescope.com and I press enter, it'll take some time and then it'll give me some information, right? So we can see certain information with regards to whatweb. So the information that I'm currently getting is from FortiGuard server. So what I want now is I want to actually get the information about the web application. So for that, I'll change this to HTTP. I'll enter in the protocol and I'll type in what I typed in the web browser. So www.moviescope.com and then I'll press enter. So we can now see that it is actually not forbidden anymore. It is actually getting us the right information, right? So this is a bit jumbled up. Let us get this in detail. What if we want all of this in detail, right? So for that, I can simply add in an option over here, which is a hyphen v, and then I press enter, right? So this will give us all of the information in much detail. So if I scroll up, I can see that the main page that I logged into with the help of this particular URL is the login page for Moviescope. We can also see the IP. So this is the IP that is resolved when I type in moviescope.com. So this is the IP that we are actually connecting to, right? We can see that the server is based in ASP.NET. And if we go down below, we can see that some details associated with all of the technologies that are being used in this website are mentioned. So the detected plugins under that section, we can see that certain information of ASP.NET is given. We can also see HTTP server information, the meta author information. So the string is EC council in this case. And down below, we can see the HTTP header information.
Now let's go ahead and understand what is SQL injection. So guys, SQL injection is basically a method using which you are able to run commands on an SQL server or on an SQL database through the user interface of a website. And then you are able to do malicious tasks such as logging into the website without even knowing the username, password of an account, or getting or retrieving the details of a particular account or all the accounts which are there on a website by running some SQL commands from the user interface, right? For example, in this session today, what we're going to do is we are going to have a look at a website like this, which is basically going to have the username and password fields. And we are basically going to check when we basically enter the username, we basically enter the password, then we are able to log in to the website. But what happens when you do not know the username or when you do not know the password? How can you inject an SQL query from this user interface and log into the website without even knowing any username and password, right? So that is something that we are going to understand. And the method of passing SQL queries from a website into the database directly is basically called SQL injection. Okay, so now you might be wondering, how does it basically work? All right, guys. So let's go ahead and first understand, how does a site basically work. So first thing that you have is a database, right? And inside the database, you will have a table which will have all the usernames, which will have all the passwords. And this usernames and passwords will then be basically fetched by a website like this, right? So whatever username and whatever password you will be entering, right, it will be checked against the names and the passwords which are entered over here. right? If they are an exact match, that is that if the email, let's say if the username is Sam and if the password is QWERTY123, if this matches exactly, that means it's a correct input, and then in that case you will get a success message. In case the username is Sam but the password is something else, let's say the password is not matching what is there in the database, in that case the output or the input will be wrong, and with that even the output will be failed, right? So first of all, we will need an application which is going to work like this. And what I've done is I've created a sample application which works exactly like this. So what I have is basically a website. So basically I have written some code in Python, which is basically going to help us have a web page, right? So let's run this code. So let me just run it quickly. Python 3 1.py. And with this, my code is now running. So if I go to my browser and if I go to localhost 5000, this is the website which I created. Now in this website, what I can do is I can enter some username, I can enter some password, and then I can sign in. I can check whether that username and password is correct or not. Okay. So what is the username and what is the password? It will be basically be picked up from MySQL. So this is the username, this is the password which I have in the database as of now. So if I enter a username which is Intellipaat and if its password is Intel123, in that case, I will get a success message over here. So let us try that. Let us enter Intellipaat and let us enter the password as Intel123. Let me click on sign in and you can see the messages login is successful. Similarly, if let's say I enter the username as Intellipaat and now let's say I enter a wrong password. Let's say I enter Intellipaat123, let's say 4. So if I click on sign in that case, it is going to tell me login failed. Why? Because in my database for the username Intellipaat, the password is Intel123. So I can add more usernames over here. So let's say if I add a username, let's say insert into user, let me enter a username. Let's say the username is sample and the password for the same is going to be sample123. Let's say this is a query that I pass and I missed out on values over here, so let me enter that. Okay, so now if I check my database, so these are the 3 records that I have. So my username is sample and my password is sample123. So now if I go ahead and if I try this out, so if I enter the login name as sample and if the password is sample123, if I click on sign in, you can see the password is login is success, or the output is login is success. If I, let's say, enter some wrong password and if I click on sign in, it will say login as failed. So guys, with this, you now get to know that the website is working, right? And this is the prerequisite that you need in order to understand how SQL injection will work. Now, what we're going to do is we're going to spoof this website into believing that I am a correct username, or the username that I am entering and the password that I'm entering is correct. Let's see how we can go ahead and understand that, or how to do that. Let's go ahead and understand. But before doing that, you will have to know some basics about SQL injection. So let's understand those basics. So guys, these are some commands or these are some syntax that you need to know in order to perform this attack, right? So first of all, what you need to understand is what is the meaning of hyphen hyphen. So whenever you enter hyphen hyphen in an SQL query, that basically means it's a start of a comment. What is a comment? A comment basically means that let's say in this code, in this Python code, if I want to make this line a comment, which when basically a comment is made, then basically that line is not processed or that code is ignored, right? So if I wanted to make this line a comment, what I can simply do is I can add a hash in front of it. And now you can see this code has now become gray, which basically means when I will be running this code now, this line will be ignored. So in SQL, if you want to add a comment, the line or the command for that is hyphen hyphen. So wherever you will write hyphen hyphen, all the commands after hyphen hyphen will be ignored. All right. Then you have something called as OR. Now what is the OR operator? OR operator basically means either of the input should be true. So if I'm using this website, either the username or the password should be correct. All right. To simulate this, let me just go to my database. So let's say I enter something like this. So if I enter select star from user where username is equal to Hemant, right? This is correct. The username is there, or password is equal to, let's enter something random. Then it should tell us whether this username is correct or not. This is a query. Let's hit enter. It says password in where clause. Okay, so not password, sorry. It will be pass. The column name is pass. So can you see it is still returning me the username and password saying that these exist. Why? Because I've used the OR operator. But this is not the correct output, or this is not the output that I want when I'm trying to log in. When I'm trying to log in, what I want to do is I want to see whether the username and the password are correct or not, right? So taking the same statement again, if I change this OR to be AND, then it will not give me any output, which means empty set, which basically means that there is no username with the name Hemant and the password this, and hence it will give me a wrong, or it will give me a empty set, which basically means that the user does not exist, and hence I will get a login failed on my website, right? So this is the difference between OR and AND. So in OR, either of the input should be there in the database, and in AND, both the input should be present correctly in the database. Only then it will give us a successful message. What is 1 is equal to 1? 1 is equal to 1 is a statement which is always true, right? And what does that mean? Whenever I will write, let's say if I write when username is equal to Hemant and 1 equal to 1, which basically means that this statement is always going to be true in case the username is Hemant, because the second condition is always going to be true, which is 1 equal to 1, right? So this syntax basically means that the statement or the condition is true, and you can use it anywhere. You can use it while you are working with an SQL query, or when you basically want to go ahead and execute a statement. So now let's go ahead and try these out and understand how will this work when you're working with an SQL query using these syntaxes. Okay, so let's go ahead and write an SQL query and let's see what the output would be according to what we have just learned. Okay, so coming back to my MySQL shell. So let's say I go ahead and first show you all the records again, which I have in the table. So these are all the records that I have in the table, right? Now what I'll be doing is, let's say I type in select star from user where Hemant, username is equal to Hemant and 1 is equal to 1. Now what do you think will be the output of this? So let's try and analyze. So what did we learn in this slide? We learned that when we use AND, then both of the input should be true. So do we have username equal to Hemant in the user table? Yes, we do. And this is the condition which we are using. So this is true. Now let's see if this is true or not. And according to what we have learned, this condition is always true, right? Now if you try and execute this, you will get the username Hemant and the password Hemant123. And then if we type in, let's say I type in a query like select star from user where username equal to Hemant and password is equal to, let's say, a wrong password. Let's say it's 12345, right? So in this case, it will not return anything. Now let's try to edit this query and let's try to apply the syntax that we have just learned, right? So what we'll do is, first let's comment out the part which we don't need. So we don't need the pass, the part over here. This is correct, but this part is wrong, right? This, because of this, the SQL query is not running. So let's comment this part out. So we'll add hyphen space. So this part is now commented. And now if we just enter 1 equal to 1 over here and give a semicolon, let's see what is the output that we get. And now, as you can see, you were able to bypass what you just wrote, right? So you commented out whatever was there later, and you added 1 equal to 1 before that comment, and because of this, this query is just executing up till here, and whatever was there after and, you have commented it by adding hyphen, right? So this is the basics of an SQL injection. If you understand this, now it will be very easy for you to gauge what I'll be telling you later, right? So now let's go ahead, guys, and now let's try and understand how we can do SQL injection using a website like this. All right, guys. So what we know of this website right now is that if I enter the username and let's say this is the correct username as I know, let me enter a wrong password over here. So what happens? Let's see. So if I enter the wrong password and if I click on sign in, I get login failed. So I want to change this, or I want to achieve that I should get login success over here. So let's see how we can bypass this feature. So as we know right now that the syntax that the current website is running in the background is select star from user, where username is this and password is this. So this is how most of the login websites basically work. Now, in order to achieve an SQL injection query or an SQL injection use case, what I will have to do is I will have to change the SQL query, or I will have to try to change the SQL query from this user interface so that I can basically bypass into the system. So how can we do that? So that can be achieved by using the syntax that we learned earlier. And let me first show you how we can do it, and then I'll explain you what would have happened. So before, whatever string that I'm entering over here, that will have a that will have a apostrophe starting before it, or that will have an inverted comma starting before it. So let me close the inverted commas first, and then what I'll type in is I will type in or, and then I will type in the query which is also always going to be true, which is 1 equal to 1, right? And then I will going to close this statement. And after this, whatever is there, I'm going to comment it out by typing in hyphen hyphen and then space. Okay, so this is the argument that I'm going to pass over here. And now let's click on sign in. So it says this field is required. No issues, you can fill this field. And now let's click on sign in. So now, as you can see, it says login success. Now, how do you think this would have happened? Let me go ahead and show you. So the query that we have in the code is select star from user, where username is equal to Hemant and pass is equal to some password. Okay, this is the query which is executing in the background. Now what I've done is I've replaced Hemant with a string which goes something like this. So I first entered inverted comma, then I entered a space, and then I said or 1 is equal to 1 semicolon space comment sign and then space. Now see what has happened. This query has now changed to this query, and I've commented the rest of the part out. Now if you execute this query, what will you get? You will get all the usernames and you will get all the password. Let me hit enter. Can you see? I've got all the usernames and I've got all the password. And because this is something which is not an empty set, the website is now telling me that the login is successful. So guys, this is a very simple and this is a very dangerous SQL injection that we have just done, because not only you have got access to the website, not only you have spoofed the website, but in case you are able to get this result set out through some method, you will be able to get all the usernames and all the passwords that are there on the database of this website, right? So guys, this is how you do SQL injection. Now that we know how SQL injection is done, let's go ahead and understand, is it really important to prevent SQL injection? So you might be wondering now, whatever I've told you, not a lot of people will be knowing about it, right? And that is actually true. Not a lot of people know about how to hack websites, or what would be the purpose of someone hacking your website. So probably it just happens to big companies like Sony, like LinkedIn, like Twitter, right? So why should you be worried about it? So that's a valid point. But imagine right now if you're doing a startup, right? Probably right now the need is not there. But if something like this happens to your website, because as we are growing towards a more technological world, a world which is more online, more and more people are getting the skill sets to work online or use the internet. And with that, if let's say somehow somebody targets your website, it is going to be a huge loss to your business, because the users which were using your website will not trust your website anymore. So to sum up, what is it important to prevent SQL injections? The point is that yes, the prevalence is going to be very less. The attack might be happening to your website, or it might not be. The chances of it happening is very less, because there are very less individuals in the world out there who can do SQL injections, right? And who would want to target a very small company that you have just started? But does this mean that you should ignore it? Well, no, because the ease of exploitation for this particular subject that we just discussed is very easy, right? And with that, in the future, as and when we are going into the future, more and more people will get aware about this particular concept, this particular technology, and hence the chances of even somebody playing around with your website is going to get you a huge business loss, right? And that's why the impact of this is going to be devastating. So that's why it is very important to prevent SQL injections, be it a very small company, be it a medium sized company, and it is important for large companies, obviously, right? And that's why you should learn all the best practices for development. You should include people in the team who are cybersecurity experts. You should have test cases in your development team, which is basically going to go and help you out in understanding if your code is safe or not. Because it does not matter if your code is just working, your code has to be safe as well. And this is why the demand for ethical hackers, the demand for security specialists is now increasing day by day, because companies have now started to recognize that yes, this is a threat, yes, this is something that needs to be addressed. Okay, so with that said, how to prevent SQL injections? Now you will say, okay, so it's very important to prevent SQL injections, but how should you go ahead and advise a company so that they can prevent SQL injection? So let's understand that. So first thing is, you should use the principle of least privilege, which basically means, let's say this website is able to, insert or select data out of the database. So this website should have a username which has the least privileges allotted to it, so that it can only do what it is supposed to do. For example, we just saw that if we use this website, we are able to list all the usernames and all the passwords which are there in the table. So probably that should be a permission which should not be allowed to the user who's going to be assigned inside your code. For example, if you have a look at the code, the username that we have given over here is root and that is absolutely wrong. You should never use root, or you should never use an admin user in your code. So it's very important to have a username which is going to have the least privileges, the privileges which will only help you to get the work done, and that should be assigned to your code. So that's point number one. Second point is that all the passwords, all the usernames, if they can be hashed in some way, then also this attack can be basically avoided. How? Because right now we relied on the fact that whatever I'm entering, it is not being encrypted somehow, and then it is plainly being passed to SQL. But what if we put in a system in between which can basically encrypt all the data or all the user inputs that you're giving, and that encryption is basically tested out in your or it is passed to SQL as an argument. So in that case, what is going to happen is you will not be able to run any SQL query, right? So that is also a possible preventive measure that you can take. And third thing that you can do is you can always employ third party authentication. So you would have seen that a lot of websites now have options like login with Facebook, login with Google, right? So all these big companies, they have gone through a lot of workx, they have been through a lot of situations, they have a lot of people who are working on the security aspect of their website, and you can be rest assured that you as a owner, or you as a manager of a tech team, if you apply your brains and try to create a model which cannot be spoofed, obviously that is not going to help you out, because the kind of feedback which Facebook and Twitter as a company gets, because they have a lot of people like you, right, who probably would be able to test the application before it goes on to production, test out with different kind of scenarios, right? And with that fact, their application obviously is more mature, right? So it's always a good idea, if let's say you do not want to go ahead and just make your application secure, because Otherwise, your thought would be just in making your application secure, whereas your stakeholders would want more features in your application, right? So if you have to balance both of them, why not use things which are already available? And with that fact, why not use the third party authentication tools which are already available out there, right? So this would be some of the methods that you can use to prevent SQL injections, and obviously there are more ways as well. So you can go ahead and practice the best practices of coding. For example, instead of concatenating the arguments like we just did in the code, you can also pass them as arguments, and that is a topic for a separate discussion altogether. But majorly, if you follow all these 3 points, they should be enough to prevent a SQL injection.
Cracking Wi-Fi passwords with aircrack-ng. Now, this is pretty straightforward how this works, right? Aircrack-ng is a network software suite consisting of detector, packet sniffer, WEP, and WPA/WPA2 PSK cracker and analysis tools for 802.11 wireless LANs. So this is a category of wireless that is going on today, and this particular tool helps you to crack the key or the access key or the password for that particular Wi-Fi network, right? So you guys might have wondered how people hack into Wi-Fi networks and gauge the password of that network. This is how you go about it. So for WP encrypted Wi-Fi passwords, which example we are going to be doing today? The example that we are going to be doing today is going to be about WEP, right? So there are other encryption methodologies as well, like WPA and WPA2, but we are going to be implementing WEP. But the method for WPA and WPA2 is identical, so you don't need to worry about other methods as well. This is how it works both ways, right? At least as far as aircrack-ng goes. So aircrack-ng first implements statistical methods and then finally implements brute force algorithms. So to find the key, what aircrack-ng does is essentially it eliminates all of the possibilities the password can have. Right? So by doing statistical methods, it eliminates a large number of possibilities. Then it begins with a brute force attack. So if the password is found in the statistical methods, well and good. If it's not, we have already eliminated a lot of other options that are possible for that password. Then we can begin with our brute force algorithm. Right? You can customize this as well, depending on what knowledge you have about the owner of that Wi-Fi network or the organization for which the Wi-Fi network is for. And based on that, you can basically implement your WEP Wi-Fi cracking with aircrack-ng. So let us understand how that works with a simulated example of a Wi-Fi network. So if you're using aircrack-ng, it'll run in a similar way as this would run. It took some time, but we finally have the key. So we can see that the password has been decrypted correctly 100%, and the key has been found, which is 9848359749. So the encryption in this case was WEP, but Aircrack also supports WPA and WPA2. So you can crack all of those passwords with the help of Aircrack-ng. So that brings us to the final part of our course here today, which is creating a Trojan with njrat. So there are a lot of ways you can actually create a Trojan with, but what we are going to be doing today is creating a remote access Trojan with the help of a tool called njrat. So this is one of the most common hacks that is possible today if security is not implemented in the target system. So remote access Trojan essentially is something that gives you remote access to the target's computer or PC or host system or host network, right? So njrat, also known as Blada Bindi, is a remote access Trojan or a rat, which allows the holder of the program to control the end user's computer or the target's computer. How does it work? It is a convenient application which helps you in creating your own rat, which directs back to your remote IP. So when you're creating this particular rat, this Trojan, what it'll ask you is what is your own IP, right? And then you'll enter your own IP. And once you've done that, you can start creating the Trojan. It will be created. There will be a file that will be generated. You can send that file maliciously to your victim's computer. And if the victim happens to run the file even once, then boom, you have access to the victim's PC, right? So which means that you have access to the victim's file system, you have access to the victim's command line terminal, you can remotely operate their computer if you have to. One of the most scary things is you have access to the victim's web camera if that is there in the victim's computer. You can get the passwords that are cached in the victim's computer. You can open the chats in that victim's computer. You can see the amount of damage that you can cause with this particular tool if it happens to run on the victim's computer. So it's usually detected by antivirus softwares, but if you're intelligent with how you implement it, you can basically get access to the victim system. Now, this is highly recommended not to try it with somebody you don't have permission, because this is something extremely illegal to do. But this is very much a practice that is followed when you are in an ethical hacking job, and it is your task to basically find how vulnerable your system is to these rats. Right? You'll create a rat and see if you're actually able to do anything with that rat, and if the rat is actually detectable by that target system. So njrat is a convenient application, helps you creating your own rat, and once the Trojan is launched, like it's packaged, it's created, it's sent and launched to the target system, it remotely connects the target system to the attacker system without the target's knowledge. So you'll just simply click on the executable, nothing will happen, and you'll think, okay, you'll move on. But you have actually started a process which has connected your system to a attacker's computer. Right now, the attacker can see all of these things. You can see it. There is a very convenient drop-down menu on the attacker's end where he can access all of that information that you can see, like the drop-down menu has all of those things. Right. So let us implement this in real life by actually implementing this on virtual machines. So we'll do that just about now. So let us implement a rat in real life and practice. So we are going to be using njrat. Now this is a tool which is used to create remote access trojans. So what this does is essentially it creates a Trojan file. And once you install this Trojan file onto the target system, you basically have access to the target system's processes, services, and file system, right? So it's a pretty invasive rat to have. Let us just begin with it. So the port by default is 5552. I'll just simply click on start, right? So once I've clicked on start, we can see that there are no lists available until now because we haven't actually invaded into a system yet. So what we'll do is firstly we'll create a rat. So we'll click on builder, right? So in builder we can simply type in the host. So the host in our case is our Windows 10 system. So it's 10.10.10.10, right? So this is where the Trojan, this is where the rat is going to report back to, right? And uh, and then I'll simply click on copy to startup, right? And then I'll click on build. So once I click on build, it will basically open up a browser window. So I can navigate to wherever I want to store my hack. So in my case, let us store our hack in the CEH tools directory. So this is the shared directory, the shared network directory in between all of the folders. So once we store it over there, I'll call it test.exe, right? And click on save. So our Trojan has successfully been created. This is our rat. Now all we have to do is run this rat on the target system, right? So let us get along with that. So currently I am on my Windows Server 2016 and we can see that we have that file available to us, right? So if I simply open up this file, we can see that absolutely nothing happens. Now, this is where the hacker gets you, right? So, according to you, the file did not work, right? But if we switch back to our Windows 10 machine, we can clearly go back and check our status. And we can see that we've hacked the Windows Server 2016 computer, right? So, I can expand this and elaborate on this. If I simply open that up, by right clicking on it, we can get a whole bunch of options, right? So the first thing that we get is the file manager. So if I open that, takes some time, but we can browse through all of the files that are present on the target system, right? We can go to the process manager, right? So this will tell us all of the processes that are running on the target system. It takes a bit of time to load, and as we can clearly see, we can see all of the processes that are running on the server 2016 computer, right? We can see the connections. So depending on the network speed that you have, it may take a little bit of time. So we can see all of the port and IP details. We can look at the registry of the target system, which is very important if you're hacking a system. And you can also access the remote shell of the target system, right? There are other options, very invasive options available to you. So you can also run a file. So this could be from your own disk. This could be a script, yeah, or you could simply access the computer's remote desktop. You can access the webcam of that computer. You can get the passwords. You can even enable and access the keylogger, which will basically tell you whatever the target user is typing onto his keyboard. You can open up a chat to basically send messages to the target system. So as you can see, there are a lot of other options as well that you can implement with this invasive remote access Trojan.
So today what I'm going to do is I'm just going to show you some resources and going to live test some website so that you guys can think how I'm doing it and you can follow those steps in your live hacking stuff. So the OWASP testing guide. So I'm going to pick the OWASP top 10 uh, vulnerabilities and I'm going to pick up the testing guide for those vulnerabilities and I'm going to show you how to test a website for those by referring the testing guide. So basically I'll be explaining what the testing guide says, what it means by those instructions written in it, and how you can actually do the testing, because then you guys will have much more clear approach to finding those specific vulnerability classes. So I thought it will be like much more useful if I just show you guys instead of just talking about it or showing you some blogs. So I'm going to clear all my history so that this new session will be only what will be available in the history. So I'll open that vulnerable website on my Firefox so that I can use it wherever. So let's start with Altero. So this is a dummy web application for online banking. So there's a sign in option and there's a search option. This this page is called contact us, just a static page, nothing dynamic here. And by static I mean when you see a page, it does not have any you know anything that will change, right? Like it'll say you're a user and there are more users on this website, right? So will this page be same for all of the users or will it be different? So this is a contact page, so it will be the same. So this page is static. There's no changing values in it. Like there's no username written anywhere. So static pages are not that insecure to any vulnerabilities. It could contain vulnerabilities obviously because even static web pages load content from the web server, but since they don't take inputs from the user or they don't show anything, any variables that they got from the user, like usernames or something. So it's not a very common place to find those bugs if the page is static. So you can proceed. See, there's a option to filling out the online form. So now this is a form that takes some values from it. Now these values will go inside a database probably. So should be another threat vector in your attack surface. So right now we don't know the attack surface. We are just going through the whole application. So why are we going through the whole application? Because we want Burp to know the application well, so that we can go later and see what all requests and responses the application is actually sending to us. Let's try out the search option. Let's put some random data. Click enter, and as you can see, it's reflecting that random data in our search page. That means we can give some payload here, some malicious payload, and it will be a part of the website here. So again, the injection things kick in. Right now we're not going to try anything, we're just going to browse the whole application. It will try to find all the issues by itself. So if you can see on the right side, it actually found some issues already. We did not run the scanner but we went through these pages, right? So Bob knew what was wrong with this page. So as you can see, this is a page that is having a issue. It's a low issue. It's not a very high issue. So the issue is unencrypted communications. That means the communication is happening over HTTP, not HTTPS. So what is it and how you should fix that issue is written here. It's very useful. That's why a lot of people use both. So I can start a new scan here so that we can also come back and compare our results with this scan. So let's go through the pages. So the first page is, so there are multiple tabs in this website. There's this online banking login, there's this personal tab, the small business tab, there's inside ultra mutual tab. So now let's start from online banking login. This is just a login page where you have to enter a username and a password, and it will log into your online banking uh, account. So that is okay. In personal tab, there are multiple options: deposit products, checking, loans, cards, investments. Let's check what is deposit products. So it's just a static page that is giving some information. So nothing sensitive or nothing very interesting here. And click on contact actor mutual, and it's again a static page, so nothing interesting. Go back. So all of these pages are seemingly static. Nothing very interesting about these pages from a hacking point of view. So let's go to small business. So I think this also has only static pages, but this page contains a form, right? This form wants your email address. So again, it's taking something from the user. It's going to dump that text or the payload to a server, or it can uh, there are many things possible with an input form. You can load something, like let's say this was enter your email, and the next step, they after you submit, they try to mail you something. So they are taking some action based on the text that you gave. That was an email. So they will definitely call a function inside their backend. That function will have to email this address something. So your email address is going into the function as an input, right? So what if you can think of some vulnerability, like when, like you can, instead of email, you can give a malicious payload that would execute some commands when it goes into the function. Instead of sending email, it will execute your command first. So it's like a lot of things are possible when the application is expecting a user input. So some interesting stuff there. Let's just try out so that Burp gets this in the logs. So it's not actually sending our email address to anywhere. So even if you have a form, I don't think it's sending your data to anywhere. I think all these tabs will have just a static page or a set of static pages. If you can see here, there's a PDF file. So inside there will be multiple functionalities, like sending
Okay.
some money, or transferring some balance into accounts. So that is the juicy part of the application, but it's most important to see the static pages, because the static
Okay.
pages like this, these are showing you something sensitive about the web server. So there's a file, but there's a directory also called PR, right? So inside this directory there might be some more files. So we can brute force all those files and get a list of files, and one of those files might contain something more sensitive. So I'm just trying to hover through all these options, all these pages, so that we have an idea of how the application is structured, and how we can target those small components. So before we start to try to hit the application with our payloads and everything, we should always have a map. So this recon process is very important, and the more time you spend on recon, the less confusion you will have in your hunting part. So let's say you are you found a web web page with a form, and you found it's vulnerable to injection. So if you are stuck, or you can't bypass the filters, then this is where the recon part will help you. Maybe you saw a different form that was not having the filters before, but you did not try it. Now if you go back there, then it might work. And if you chain those two things, then it might give you a bigger vulnerability in hand. So it's very fruitful to explore the application and know every little thing, like how the PDF is loaded or where the PDF is loaded from. So that's where the recon process is very useful. So these are the actual functionalities of the website on these tabs, right? So let's try to log in first and then try to. So for login, we need that page open where it had the username and password. So this is a normal user account and this is an admin account. So obviously we should try with the normal user account to see what all functionalities are available to the normal user. And then once we are familiar with all the functionalities and all the bugs, we can try to find the bugs in admin account. And then we can go back to the user account and see if we can hack the application in a way so that we gain admin privileges without the admin password. As you can see, we have an option to see account details, and we have 3 accounts here: one savings account, one checking account, and one credit card account. So let's see the account details for the saving accounts. So this gives some data, and as you can see in the URL, there's a function called show account, and it's taking a parameter called list accounts, and we are giving it a value. So just to try, can we see this? Yep. So this is not our account, right? 8,000, 8 lakh one, but we are able to see it. So we found one vulnerability already. This is called IDOR, or indirect object reference. So now I'll go back and talk a bit about that. So which vulnerability class did we just found? So it was broken authentication. Why? Because we need to be authenticated to see the data for that user. But we just gave it to the application and it took it and showed us the data. So IDR is like very common. It's like the most common vulnerability class in web applications. So I'll just search for it. Insecure direct object reference. So we are directly asking for the, and it is giving it to us. So it's insecure direct object reference. So now how is it working? It's working because the application that is responsible for giving these details, it forgets to check if we are allowed to do that. It is just taking an ID and giving us the data. It should check if the cookie that it set for the user having this account number is asking for it or not. But it fails to check that, so we are able to see all the data. So what we can do is we can list the accounts for everyone. Okay, so now we got another vulnerability here. So I gave it list accounts equals 1, and it is showing some internal error, right? But this error page is not just an error page, it is showing us some stack trace that is coming from the programming language. So clearly they are using Java. As you can see, this is JSP page, Java server pages, and it's printing out some printing out some programming language instruction. So they are using a for loop, and in the for loop they are doing all this stuff. So if I'm an attacker, I can read this logic and try to figure out how I can fool the system. What can I give in this function? What I can give in this account variable, so that it goes in, and if this happens, then it will break this function and I'll get something out of it, or the application will get hacked. So what is this? This is another vulnerability that I just found, and let's go back to the OWASP testing guide, and it's called sensitive data exposure, right? So 2 classes of vulnerabilities: broken authentication and sensitive data exposure, just by one URL. And let's try this. So we gave it a malformed input. It was expecting a number. We gave it 1 and 1 apostrophe. So did it behave differently? Yes. As you can see, the root cause changed. Now it's saying number format exception. Before it was showing some other exception, null pointer exception, right? This means there was nothing found for this user ID 1. But if we don't give it a number, it will say number format exception. That means this number format is not accepted. So this is not insecure or any more insecure than it was before, because we are not breaking the application. The application is understanding what we are giving it. We are not giving it a number, so it's telling us to give a number. So it's okay. So as you can see, the testing guide has this IDOR page. This is one kind of thing that you will find in most applications for loading data for some user or loading data for some ID. The ID will get passed in the URL. Just like the ID, it can load some username also, like change password user equals some user. There was a change password function, and it took a email address instead of a username. So it's just the same kind of thing, right? So instead of a username, it can also take a image, like which image. So let's say this is a function, show image. It is taking a image value. So let's say you're on Facebook, and on Facebook you have the permission to hide images, right? If people block you on Facebook, you can't see those images that they upload. But let's say Facebook had a bug. It was loading the images using URLs like this. So in this case, you just need the image ID of that user. You don't need to ask that user to give you permission or something. So if it tells you the image name or something, you can just put it here. And if the Facebook application is vulnerable, it will not check for anything if you have permission or not. It will just show you the image, because this function probably won't have any checks to check the cookie value or your token value or the username. It will just show you the image. So if the user has bugged you, then also you will have full access to seeing all the data for that user. And same like menu item equals 12. So this is showing if you don't have access to some page, you're not the administrator, you should not have the option to delete other users of the application. But let's say there's a page like this, there's a URL like this, access page equals and menu item equals 12. So you can just directly call it, and you can pass any menu item even if you don't have permission to that menu item. It will show it to you. So it's like very common, and it's like there will be hundreds of links like this in the application, and the developer will fail to fix at least like some of them. That's where the hackers can use those sensitive URLs and find out all the IDR bugs very easily. And as we just saw, it was just there. You just had to change the URL. No scanners needed, no burp suit needed, nothing. Just change the value here and we saw the data. So let's go on to the next option. See, in this page there was a click here to apply option also. Let's see what that is. So it wants us to apply for your $10,000 Ultra Mutual Gold Visa, and it wants our password. So let's try it. This was our password, and it says your new Ultra Gold Visa will be sent in the email. But since we have not hosted this application ourselves, it is hosted by someone else. We don't have access to the email. So I suggest we host this application ourselves. We can do that. Like there's an option here. See, this is a code for this application. So you can just go and host it on our server, and we'll get the email also. So there would be some bug in that email also, but we can't see it right now because we are using the already hosted version of the application. So instead of doing the account summary here, we can see recent transactions. Oh, actually we missed all the options here, right? There was a checking account and there was a credit card account. Let's try that credit card account option. And there are some options here also. Oh, here you can select the account directly from here. So does the IDOR bug exist in these credit card options also? Let's try. We gave it a 9 and it said null pointer exception. That means nothing was found for 8 9. Let's try 8 7. Again nothing was found. So no, IDOR is probably doesn't exist here. But we'll try a bit more. Yeah, this works. This is very similar to the savings account option. But we have to try all the options because some options will be vulnerable to something and it will be secure for the other option. So let's check the other option now, that is view recent transactions. So this is page that shows you your recent transactions just like a normal bank like HDFC or ICICI. It's very similar to that. So let's give it a date. So I want to see transactions from 2018 January. So yeah, it shows us all the transactions. But one thing you should note that we don't have anything here on the URL. That means it's sending a payload in the body. It's not going through the URL. So I write there are two parts of a request. One is the header, one is a body. So actually there are, if you talk about it, there are three parts. One is the URL also. So URL is not, it's a part of header, but it doesn't count in headers. URL is just, the path request where you are sending that request. And what you are sending, that is, divided into two things. One is your header, second is your body. So I'll explain it to you in both. So this was the function that we called. Let's send it to repeater. So this was our URL. As you can see, it's a part of the header only, but it's not actually a part of the header because it says where to send this data. It doesn't show what you are sending. In previous case, we were sending the ID 8002 or 8 lakh 2 or 8 lakh 3 that was going in the URL. So now that ended up in the header part itself, but people don't usually count it as header. So right now we'll just count it as header because you can see it more clearly that way. So it's making a post request. The highlighted part right now is the header part and this is the body part, and there's a cookie in the header also. So this cookie was set when we logged in into the application. Like we got a 200 OK response for this, and we got all the transactions. So now if you think about it, what a hacker can do with this. So if you can see here, right, there's a alter accounts cookie. So what is it doing? It's identifying that if you are the guy who has the permission or not. So when we send this request to the server, how does the server know which accounts the user wants to show the transactions of, or which accounts does the user has permission on? So let's take this. Maybe some data is in this value. I'll copy this. So these things won't be like that simple in real web applications, but it will be like very similar, and in some cases it will be much more easier than this. It all depends on the application and how tested the application is. So I'll paste it in my decoder. So what decoder does is it will try to decode any hidden values in these strings. So this might be a a hidden encoded string that contains all the account numbers. So we can just change those account numbers, encode it back, and send it in the request. So let's smart decode this. It does not work. Let's decode it as base64. So as we can see, right, this was not readable at once. It was looking like some random garbage data. but once we decoded it as base 64, which is a very common encoding scheme. So it was actually an encoded string that contained this, your account number and the account type and some value. I don't know what value it is. Your checking account number and again some value, and your credit card number and again some value. I think these are balances if I'm correct. But let's say I want to, like, I don't have permission to see the saving account details for some other user of 8001, but I'll just change this. I'll encode this as base 64, so it's again now some random data looking like garbage to us. Then I'll send that value again in a request, and I'll see if we are getting the answer for that or not. So yeah, we are getting. So in the request, there are some values here. So we wanted the data for 8001, correct? So was it available to us? I can see 8003, 8003, 8002. Sorry, it's 8 lakh. I'm sorry. So yeah, nothing for the 8 lakh one guy, right? So let's try something else. Let's change this 8 lakh 3 to 8 lakh 1, and then again encode it. So just to make sure it's encoded properly, you can decode it again as best as before. 8 lakh 1, 8 lakh 1. It's correct. So if you think about it, how the application is now sending us the data for the proper accounts, right? So I think maybe it's because of the other value that's called jsession id. So this is the id of your session. So it knows which session you're having the permissions to, and this session should only be given the account values for these specific account numbers, not all of them. But since this is a vulnerable application and we should treat all the applications as vulnerable, we should still try to play with those options. So what I'm going to do is I'm going to remove that header. I'm going to remove this session ID, and then I'll see if they are actually checking the session ID or not. So let's do that. Now it did not work. Obviously it logged you out, and then it wants you to log again, so it can set the session ID. As you can see in the location header, it's giving login.jsp. That means it's telling you to redirect to this page, login.jsp. So when you redirect, you'll have to log in. So let's go back and put the header back there. So I put the header back, send the request. We again have the data. So I'll say it's not like insecure to the IDOR bug here, right? Because we tried to encode the values, did not work. So what more can we do here? See, if you look closely, they are sending three values: the savings value, the checking value, and the credit card value. And they are using this symbol to split those three values. So what if instead of removing the 8001 or 8002, we add some more stuff to the later part? Maybe that will work, because it will say, okay, these are permissions to these, and there's an extra value, so it might give you the result for that also. So just for the sake of trying, let's try that. So I think it did not work again. It was still not giving us the values for 8 lakh and 1. Very insecure here. Maybe there's some other you know vulnerability class that we must try to find out what's wrong with the page. But for now, let's let it be. Let's skip this part. Let's go to the next feature of this application, that's transfer funds. So in this, you can transfer funds from one account to different account. So you can transfer the fund from the 8 lakh 2 to 8 lakh 3 checking account, and you can give an amount. Let's say I give an amount of 1. I click on transfer money, and it says it was successfully transferred from account this to account that. So now let's see what happened. So this was the page, the transfer. So again, let's enable repeater. So now the body contains, instead of containing dates, right, before it contains some date values, it contains some other values like which account number to what account number, and the amount, and what it has to transfer. So transfer money. So let's send it. So again, it will say the same thing. Let's search for it. Yeah, it says one was successfully transferred. Okay. So if I'm a hacker, right, or how can I manipulate this user, the demo user, to send money to my account? What I can do is I can craft a page for it, and I can give the link to the user. He clicks on that link, and the account, the after the click happens, it will send a request to the bank to transfer some money from his account to my account. So that's on a very fundamental level how I can hack the user to send money to my account, right? So now we are going to talk about a different class of vulnerability. It's called cross-site request forgery, or CSRF. So that's what we can use here to trick the user to send money to our account. So I'm going to show you how easy it is. But since this is a post request, it will be a bit tricky, because we need to send some data using the body, right? It will not be just a link that contains some values like this, 2 equals some value. So now it's not just a URL. We have to send the whole page, the whole body, and the headers. So I'm going to right click. So burp makes that simple. So instead of doing anything, I can just right click. I can click on engagement tools. I can say generate CSR POC. Click on this. This will give me a HTML page, right? So now this is the malicious crafted page that we had to create. As you can see, it made a hidden form. So this is a form, and he'll just give it a link. So whenever I click on it, right, and I push submit, it will send an action. It will send a request to this URL, and whatever value we give here, value 8 lakh 2 to 8 lakh 3. So if I'm an attacker, my value is 8 lakh, let's say 6, and I want to transfer 100 USDs. So what I'm going to do is I'm going to copy this HTML, host it on my server. So let's test in the browser and see how it happens. I'll just copy it. So instead of hosting it, Burp is already hosting it for you. Just need to open it in the URL. So this is a Burp URL. So see, if I'm a user, I don't know anything about this. So I can go back and do some trickery here. So I'm a hacker. I created this web page that says press below to win an iPhone. So now I send this URL to that innocent victim that has an account in the bank. So if I click here, so the victim will not know if this is a bank page or not. It will just have some URL and some data. So if I click here, he will think he is going to win an iPhone, but actually what it's going to happen, it's going to trigger a request to this bank transfer account and send the money. So let's just try it. I clicked on it, and this was successfully transferred. So now the iPhone page disappeared, and the bank page popped up saying it was successfully transferred from this account to that account. The user never filled up this form, right? He never thought he's making a request to the bank account, but it happened, and now the victim is short of 100 USDs. So it's as simple as that. So even if some page doesn't look like it is trying to hack you, it's actually, you must read the source what it's going to do, because if I was a very clever user and I got a link like this, I will not just right click a button on this. I'll first right click and view page source, and then I will know, okay, actually it's not sending any data to that. It's not going to give me an iPhone. It's actually running some scripts. If you can see, this body tag, right? And it's not actually what it says to be. We don't have this title, we don't have this href or anything. It will be much clearer if we just right click and inspect it, because it will not load anything. See, now we are able to see the real values behind this button. It's actually trying to transfer the money, and I'll not click on it now. I know what is happening in the background. So most of these frauds and the hacks that happen every day, it happens because of users not knowing if it's a ad page or just a page that is trying to hack them. But this click here might make some changes in some other account. Maybe send a mail on Gmail to some other account, or it will send some friend to Facebook to some other person, or download some file to your system. You can basically do anything to a victim who doesn't know what SRF attack is, and this is how it works. So now, how do browsers save themselves from the CSRF attack? Let's say the bank was set to the CSRF attack. How would we know that? It's very easy. I'll just open a common website to demonstrate that. This is google.com. So in the response.com, you can see there are two headers here. I talked about the first header yesterday. XSS protection. That means the browser won't let anyone hack your website using XSS. And there's the other X-frame options. So the other ones, your browser won't load this web page using any other website. No other can load google.com in a X-frame or in a hidden part of the website. So if google.com loads anywhere, it will not be hidden. As simple as that. So what sites can load google.com? Only those sites which have the same origin. That's what this header means. So same origin means which are hosted on google.com itself, not any other origin, not any other domain. So that's how So this doesn't save you from CSRF actually. This will save you from other vulnerability called clickjacking. So now clickjacking is similar to CSRF. In CSRF, we sent a form we saw in the previous attack. So this was a form, right? The form data went to some website. But in clickjacking, we don't send a form. We might send a form if there was. So in clickjacking, it's called jacking your click, right? You are hacking a click. So there was a click happening here. So this might be delete my account click, right? So instead of the submit request button, there's another button under it that is saying delete my bank account. So if a user clicks on it, it will delete the user's bank account. But he doesn't know because it's hidden. So if there's a click there, it's not actually a button. It might get confusing right now, but I'll just show you the documentation, you'll understand. So I'll just search here for clickjacking. So clickjacking, also known as UI redress attack, is when an attacker uses multiple transparent or opaque layers to trick a user into clicking a button or link or another page where they were intending to click on the top level page. The attacker is hijacking clicks meant for their page and routing them to other page, mostly owned by another application, domain or both. So the user will think he's clicking on some other web page, but some critical or banking application or some other application will be hidden on that button. So the user clicks on win an iPhone button, but he's actually clicking on block my account button. So it's very similar to CSRF. Both are you know executed by the victim's lack of or victim's full trust in the application that it is. So now we covered another two web application bugs. Let's keep on traversing our vulnerable application. So there's another option, search new articles. Here you can search. So I'll search for, so there's some example also. Search for watchfire itself. Instead of I search for A. So it found these. Unix was created, Jesus was born, watchfire announcers. So three news articles were listed from the database. So let's try to do some SQL injection. So again, new shuttle not found. So it looks secure enough, but we can't save unless we see the whole picture. This is what we are sending via our queries. So our query is going and the response. This is the response. So it's sending some request to this vxpath.jsp and it is sending the content and it's sending the query. And let's execute this. So now we have first this application. To make it break or something. So I searched for a blank news title and still found three results. And this is coming from the database. If you can see here, it is searching the database. That means it's going in as a query, right? So either we can try all of these. Let's try double quotes. We are just trying to break the query. As you can see, we already broke it. It gave a 400 byte request. But from a point of view, this is not very useful. It's not giving us any sensitive data or it's not performing malicious actions on behalf of us. So it's not very useful to us right now. Single quotes is not breaking the application, but double quotes is. So we note this somewhere. Right now it's not of any use, but maybe later if you figure out some other attack vector, you can change this and it will be very useful. So this is our details. So it's sending requests. So for each request, it is 0 right now. But if you see here, we have found 3 critical issues, 16 medium issues, 217 low score issues. So let's jump to the critical issues. So 2 critical issues were found. So these 2 pages were found to submit sensitive data such as password or username over unencrypted connection. So very sensitive because if you're on a Wi-Fi network, let's say you're using your bank account, a public network, let's say you're traveling by train or flight and you're at the airport and you wanted to see your account summary, but you don't have any internet on your phone. So what you connect to the airport Wi-Fi, and when you connect to the router, all your data from your web browser will go to the server via your router, right? Because you're on the internet connection of the airport. So 100 more people are connected to the same router. So one of those guys actually start a network sniffer that will track all the packets, all the requests going through the router. If your connection is that means it's not HTTPS. Then all your data, your passwords, all your usernames, he can easily see just as clear text. So you'll be thinking you're just using a Wi-Fi, but you're actually sending your data out there to the router, and anyone can actually ask the router what data is going through it. So people should not use these websites that use HTTP. As you can see in the host part, you can see it's HTTP. So that's one thing. Let's see some medium issues. So medium issues are also mainly unencrypted communications and transport security. So it's about SSL. So nothing very sensitive. But as you can see, there's some cookie issues also. So it's saying cookie scope to parent domain. What does that mean? So that means the cookies are having the scope cookie that is set by the web server. It also tells the web the web when it's setting the cookie. It tells it which domain or which subdomain this cookie should be valid for. Let's say you're using two websites. One is uh, drive.google.com and one is google.com, right? For using Google Drive, you'll need a separate cookie, right? And for using google.com, you'll need a separate cookie. Why? Because the web server that is running google.com told your browser to not set the same cookie for it. But in this case, the cookie is scoped to the parent domain. So you use a website called www.zomato.com. So the cookie is scoped to zomato.com, right? So if you're using www.zomato.com, the cookie is valid for both zomato.com and www.zomato.com, both domain and the domain. So let's say there was a bug that allows the attacker to cookies on the subdomain. In that case, what will happen? He can steal the key that was scoped to your parent domain, and now he can hack all the subdomains, even if it's .zomato.com or you know order.zomato.com or anything. You can hack all those websites because the cookie was scoped to the parent domain. It leaves all the subdomain and the domain itself vulnerable to this cookie hijacking thing, or actually steal the cookies using a XSS vulnerability or the JavaScript injection thing that we saw yesterday.
Okay.
So now there's a new thing called client-side JSON injection. This is just a fancy word of a fancy injection technique that's not very common, but it's good to know. So if you can read, the issue is written in detail. The application may be vulnerable to DOM-based client-side JSON injection. Data is read from the question.hash and passed to JSON.parse. So actually using some JavaScript function calls to track down the vulnerability. So what is DOM based? So I'm going to just tell you on a very basic level. So a DOM is the object model of the website. So this is it looks okay, but it doesn't look like this to the web browser that is running. It doesn't look like an image to the right side or a red on the bottom side. No. So browsers don't understand what is where in this format. Browsers understand it in a tree kind of format. So that is the DOM or the DOM tree or the model. So if I right click and I press inspect element, as you can see, this is a HTML page and this is having a tree kind of structure, right? So this is actually creating the DOM structure of the website. The form has to be kept inside of a div tag or a division tag, and that will be again inside a TD or a table data, and then in a table body, and that will be again in the table, and so on. So DOM is what is DOM? DOM is nothing but just a representation in which the browser understands the website or the web page. So it's very fascinating, but not that severe. That's why it's tagged as severity low. That's okay. So let's leave Burp to do the crawling. It has 16.5. As you can see here, these may requests. After it completes request, it will show you a report of all the bugs that were found by Burp. So let's come back to our web application. So we tried to hack this, nothing worked. You can try some more by giving it that kind of data. So it won't work right now. So we can leave it for later. Let's move on. So you have now customized site language, right? So you have terms here. You can set it as international or English. Let's set it to international. It made a request to customize to JSP and send to lang equals international. So maybe we can execute some code also, but we will come back to it later. The main objective is to do maximum harm or to prove the maximum impact of the uh, hack, right? Because unless you compromise some account or you compromise the web server itself, there's no significant impact. So let's see how we can compromise the account. So I'm going to show you, how things work in the real world. So this thing will be like, very common. You can test it in several other famous websites, and I'll not be surprised if it works there. It should reflect it in your web. That's where your data is ending up. So let's enter some more. Enter some harmful characters. So these were harmful characters. Now it looks okay here because it's reflecting it as you entered it, but we should still see the page source because unless things were reflected as it is or were they encoded, because see in the URL the things are encoded. My less than and greater than brackets are gone. Instead of those there are %3a and %3c. Those are the encoded values for those brackets, but in the page source they are as it is. So we can add our tags, we can add our scripts. So our objective is to steal this user's cookie just by giving him a link. And once we steal his cookie, we'll have the cookie value and we will use those to transfer money from his account. So it's like a very common application. So I'm just going to demonstrate that. So let's say I use this payload. So you can see here, input is ending up in between some paragraph tags, p tags, one here and one in the bottom somewhere. I don't know. So let's try to break out of it. Or we actually don't even need to break out. We can just put our script tag there. Let the script tag run inside the paragraph tag. We don't need. So our script is now inside the source. So if I remove the page view source, I can see there's a script and it is popping up a alert. So now instead of popping up the alert, we are logged in, right? There's a sign off option. Instead of popping out the alert, I'm going to pop out the cookie value, right? So about that. So before I told you there's a document object model, right? So the different object model gives us several functions to access the documents at. So now a document might contain several attributes like this document belongs to domain, what cookie does this domain have, or which subdomain it is, and more. You can read more about it by just searching the document object model DOM. on Google. There will be many results and you can read in detail. So the option that we want here is document. So this will alert or print out an alert on the saying the document.cookie value. This will not print document.cookie in text. Yep. So you can say we have the cookie value here, right? So if we send this URL to that user, he will see an alert like this, but this will not send the cookie to us, the attacker, right? We want this cookie. We don't want to show him the alert or something. What we can do is we can send this cookie to our server, right? So how we can send this cookie to our server? We can, when you request a page source, let's say I'll go back to the example here. When you requested this page saying /bank/querypath.jsp on this website, the server understood that you file and you are giving these parameters, but it also logs it somewhere. There are things called server logs. So whatever you request on any web server, it is going to log it somewhere that some user wanted this path. And by logging, I mean write this line in that log file or a normal text file. So what you can do is we can make us to our server, the attacker server, and log the session cookie. I'll just show you how to do that. So this site is loading the Google image from Google server. So it's making a request to this URL to load this image. So when I make this request, the Google server will log this URL, the whole URL. It will be in the logs because we requested for it. So what instead of this Google URL, I have a attacker server called attacker. So what this did is it made a request to attackerserver.com and the document.domain. In the server of the attacker, we got a log that one file was requested and the file was https www.attackerserver.com slash the document.domain value. So if we put document.cookie value, we saw what was the document.cookie value that popped up that time, right? So it will append after this. So that means your cookie is being sent to a server log to that server which is controlled by the attacker. So I just need to give this to that user. He will request this URL by clicking on the link, and I will get the session cookie of this user in my logs of the server. So I just need to open the text file, copy that cookie, and paste it in my here. I can just paste it here. Instead of mine, I'll paste the user's cookie, and I will have access to all the session values. I can make all the requests behalf of that user. Yeah, the transfer account, where we had to transfer balance from one account to other, where we used the CSRF to transfer the money from that user to the attacker's computer or the account. So there would be more bugs, SQL injections, local file inclusion, remote file inclusion, cross-site scripting, server-side request forgery, and more. So this application is supportable. That's why we are easily finding those bugs. But when it's a internet website, it won't be that easy. It won't be just a search option, and you can directly enter your payload. Thing is, all the search options work the same. So if in Google I entered something, Google also did the same thing, right? Google also went with that term, searched on database, and printed the result, and also your query. Why is Google not hackable using this? Because they filter it. When I enter something, they don't normally just like, okay, this user entered some keyword, I should just print it on the web page. No, they don't do that. What they do is they think whatever the user enters is malicious, so they filter it out. They will filter it out. They'll remove all the less than bracket, get them bracket, quotes, any characters that can trigger a bug. they will remove all those characters and then print the screen. So that's how they are secure, and that's how most of the websites will be secure to these kind of stuff. But even Google could not do it properly. There's a who actually found the in Google search. You can read about it. It will, make more sense to you. This researcher called Masato, he found this cross-site scripting. So he entered this payload instead of a normal payload that we entered that time. He entered this payload, and he was able to execute the script in Google. So he would have stolen all the cookies of all the Google users. So it was everywhere. It's not like there's some different approach to hacking the forms on the page. It's the same, because you enter some data. If they don't filter it, they don't sanitize it, it is going to create troubles somewhere on the database, on their backend, or maybe on the front end itself, like happened right now. So you must read about these, how it happened. You can try those same steps on several other websites. I will start with cryptography first. Cryptography is nothing but just converting data into secrets, converting readable data into something unreadable by a human, or converting meaningful data into garbage data. But that just looks garbage. It's not actually garbage. So what do I mean by that? So let's say there's a string called password123. This is your password, and you don't want to show it to everyone else. When you enter this password on your system, you want to you want this password to leave your system in a totally unrecognizable format. So what do? Do you like decode, encode something to change the appearance of this text? So you will convert it into something like totally random. If someone reads this text, he will not be able to make any sense. But this represents the same thing. That is this string. So why? Why do we need to do that? As I have been talking about, like every link in a network could be attacked. Let's say you are communicating to a server, and you are sending some sensitive data such as messages or passwords or credit card numbers through your device, through your mobile phone. You entered some credit card number. So now the links in the network, connecting your phone to that server, they are huge. There are a lot of those links. There's a router to which your mobile phone is connected. That router is connected to an ISP, your internet service provider. Now, when I say ISP, it's not just one computer. There are like series of computers in that ISP that route the traffic from one server to another, and so on. Now, after the ISP, there will be some hops in the network, some other DNS servers or anything where the data goes through. And after that, there are routers or the network systems of the server. And then comes the load balancer that is above the server, that balances the load between different servers. And then there's the actual server. So that's the most simple flow of how your password or the credit card number will pass through the network. So if any of those links in the network is compromised, the attacker knows your password, that is password123. So you can't just send your password in plain text, right? So you want to encrypt it, or instead of using the word encrypt, let's use the word hide, or use the word convert, because we'll talk about encryption more later. So you convert it into a form that is a totally unreadable to a third party. So he would get this text, but he won't make any sense out of it. He won't know if this is a password or how to convert this text into your password, the actual password. So that is why encrypting the data is important. So okay, so I think that's clear why we need to encrypt. Now I would like to add one more thing here. I think I forgot it. So there's two things. There's encoding and there's encrypting. To a normal non-security person, these two may look like the or sound like the same thing, like converting something into something else. But from a security perspective, they are very different. So encoding means converting one form of data into another form of data. Encrypting is the same, just encrypting means the end goal of encrypting is to make it more secure. Encoding the data won't make it secure. So let's say you have data, this is a string, you encode it and it will become some other string. But you can also decode it, right? And you decoded it and it becomes another string. Now when you're encrypting the same data, it becomes some random string, but you can't just directly decrypt it. There are other uh, processes that you have to do to decrypt a data that was encrypted before. So encoding, decoding, very simple. You don't need a password or a secret or a key to encode or decode a data. You can encode any data and you can decode any data into the original data. So why do people use encoding, right? They use encoding to convert the data into some format that is fault proof. They don't do it for security. So one famous encoding mechanism out there is called base64 or B64. So this will take the data and convert it to some random you know string. So there's a base64 encoder online that is very useful. Base64 is just one of the encoding mechanisms out there. There are many, but this is the most commonly used. So I put a string, then I encode it, and this is the encoded version. I'll just copy it and I'll just decode it. I'll put the encoded version and I'll decode. It gave me back the string. So if I encode my string into this and I send it through a network, an attacker can still get this string. He can decode it on his end. So there's no security or uh, it's not protected. The attacker can easily decode it. He doesn't need any processing or time to do it. So why people do it? I was talking about that. So people do it to make the thing fault proof. Let's say my name was no, the E was not a normal E. It was let's say some other language. So let's say the E is a Chinese E or some character. Let's say my name is this. You can see this R is not a normal English R. So if I pass it through my system, it will go through several other softwares, several other web applications, several other servers, and some of them might not be able to read it, right? Because some will understand English, some will understand some other dialect. So some can fail on this unique character. So if I encode this unique character will become this, right? Normal English, normal words, normal symbols. So every other computer can read this. There will be no fault in this. No other software will break because there was a special character in it. So it made the whole system, fault proof. That's why we encode the data or converted the data from one form to another. So the end goal was not security, but it adds a bit of a layer of uh, you know like it makes it a bit secure. It's not as obvious as it was before. It still looks random. So if someone is running a tool that is sniffing all the plain text words from a router, he will see this. His tool will see this, and it will say, okay, it's just garbage, some random bits and bytes. He will just skip this. So it added a layer of security on it, but that was not our intention to do it. If the hacker is a bit more cautious, he will know that okay, this is a disk for encoded string, and I can just decode it. That is easy, but makes a bit safe to encode the data. The best is to encrypt it. Nobody can just take this string if it's encrypted and convert it into the real data. He will need many things to do that, and it will be almost impossible. I'll not say impossible because theoretically it's possible, but in a real world, the practical world, it's not possible to decrypt a data without knowing the secret. Encryption, as I talked about, it's you know converting the data to enhance the security, to hide the data. Now there are three kinds of encryption: symmetric, asymmetric, and there's a process called hashing. So what is symmetric? So symmetric hashing is when you have some data and you have some secret key. So you came up with a secret key. Let's say this was your password. So the real password that you use on the website is this data. So I'll just write it here to decrease the confusion. So let's talk about it from the web developer's point of view. Let's not talk about it from the user's point of view because he doesn't know how encryption works. He'll just submit his password. Now, before going through the network, it's the job of the web developer or the website owner to ensure the encryption of the whole data flow. So I am a web developer. Let's say I made Facebook and people are going to submit their super sensitive data on my website. Now it's my job to protect them from hackers. So I heard about this cool encryption technique called, you know, let's say AES. So it's an encryption algorithm. So what I heard about this is, you can use this algorithm over your data, which is user's password that is submitting, and it will convert it into some encrypted data, which I can pass through the whole network flow. So how do I do it? I'll take the data submitted by the user, that is his password. I'll come up with a secret key of my system. The secret key will only be known to me, no one else. It will just be stored on my server. So the secret key will be some random digits. Now I'll encrypt the data and come up with this encrypted data using my secret key. Okay. So now when this data reached the end server, I need to decrypt it. I need to know what was the password of the user. So next time when he comes, I'll compare the two passwords and know okay, this is the correct password or not. So I'll need to decrypt it. So how to decrypt it? Again, I will take the secret key. I will add the encrypted data and I will have the password that was submitted by the user. So what is like going on here? So simple. We had a secret key which can convert the plain text password into an encrypted password, and the same secret key can convert the encrypted password into the plain text password. So it's symmetric. From whichever end you look, you're using the secret key with an algorithm that converts a plain text data into encrypted data. Same for decryption. So the whole encryption and decryption process is symmetric. That's why it's called symmetric encryption. So is it like secure enough? Is there any fault in this methodology? Obviously that there is. How do you enforce that this secret key is hidden to your system? Maybe someone hacked your system directly and he stole your secret key. So now again all the users are now again insecure. even though you are hashing their data, but if I have your secret key, whatever data I see, I can just decrypt it using the same formula. I'll use your secret key over the encrypted data and I'll get the data. So once the secret key is compromised, all your data is compromised. So again a weak link in the chain. So symmetric is strong, but not that strong because there's still a weak link in the chain. So then people came up with asymmetric encryption. So now what is asymmetric encryption? So with asymmetric encryption, people don't have just one password or one key. People will have two keys. One will be called public key, the other will be called private key. So how would that work? So let's say there are two people, person A and person B. So person A wants to send some message in an encrypted format, and he wants person B to receive that message and read that message. But he doesn't want to share the password to encrypt or decrypt the data. So if we go back, let's say the person A used the symmetric encryption instead of asymmetric, he will need to transfer the secret key to person B here, and then he will only be able to decrypt the data. So what happens in this case is person A, he will encrypt his data like this. He will take his data. So what did person A do? He took his data, or let's call it message. He took his message, he hashed it, or encrypted his data using his private key, and he encrypted that data or encrypted his message, and he sent his public keys. So do note that he has two keys. So both of these guys have two keys. A had his two keys, he used the private key to encrypt the message, and he sent the public key to B. Since it's public, even if anyone else gets the key, that's fine. So private key, when B got the private key, he can use the public key of A over the encrypted data. Will he get the decrypted data or the message? No, he will not get, because that was the problem. So I talked about this case before we actually talk about the real case, to show the contrast between the symmetric encryption and asymmetric encryption. So the contrast is, whenever you have some private key with you and you hash your or encrypt your message with that private key, it is troublesome. So what do people do is, to tell the real uh, fundamental, or the real how this asymmetric encryption works. First, I'd like to tell you guys that this encryption is being used everywhere right now, and theoretically it's like foolproof, and it is. You will get to know why very soon. So let's say B had his two keys. So B private will be only with B. B will only hold this private key because it's B's key, and there will be a public key. So now B will publish this public key everywhere. He will tell everyone, whoever wants to send me any message, just encrypt your message with my public key. So if anyone wants to send him a message, he will encrypt his message with the B's public key. So A saw that message, he encrypted the data, his message, with B's public key, and now he got encrypted data. Now instead of giving anything to B, that's the real broken chain, real vulnerable chain, to pass the key to someone to decrypt it. We remove that chain. So now B will use his B will use his private key, that is B private, over the encrypted data, and he will get the message. This time he will be able to get it. So if you think about the whole flow, other than sending the encrypted data to B, nobody sends anyone anything, right? Everyone had two keys. Nobody sends any key to anyone. If B, wants anyone to message him with his encrypted data, he will have to send his public key to everyone. So he'll make his key be public to all, anyone out there. Will that harm be in any way? No, because you can only encrypt using the public key. The decryption will always happen with the private key of the same key that was public. So one can't encrypt a message with A's public key and decrypt it with B's private key. It won't work. So every key comes in pairs. So this is one pair B. A will also have the same pair. So everyone will have two keys. The key that other people will use to encrypt a message will be the public key, and to decrypt a message, the person whose public key was used to encrypt the message, he will use his private key and he will get the real message. So no transfer of keys anywhere, everything is totally secure, and it works because it's being used by all the hot technologies out there. So even this SSL certificate that you're seeing on your screen right now, I'm not sure if you're able to see it or not. So if you click on your, yeah, I think you are able to. So this certificate that was issued by google.com, Google Internet Authority, this is also using the same mechanism, public private key mechanism. So if you can see here, the public key is public. We can use this same mechanism. There's a signature here. This is the key. So the key is of 256 bits or 65 bytes. And which encryption does it use? It's also written here, SHA 256 with RSA encryption. I'll talk about that. So when I want to send a message or any data going through my laptop right now, it's using this public key of Google and encrypting that message. And when it reaches the Google server, Google uses its private key and decrypts the message. So the biggest application of this asymmetric encryption right now is the SSL, or the secure socket layer. So which converts our HTTP websites into HTTPS websites. So it makes it more secure. So again, the same thing is happening. The server will give us a public key. We will encrypt the data using the server's public key, send the encrypted data to the server, and the server will decrypt the data using the private key. Simple. So all the encryption, even the WhatsApp encryption or the Messenger encryption, everything happens like this. So some days back, you guys have heard that WhatsApp made the end-to-end messaging encrypted, so that WhatsApp itself doesn't know what the users are sharing, the messages. So even if WhatsApp wants to know what one guy is sending the other guy, they will not be able to know. So how does that work? So instead of encrypting your data with server's public key, what you do is, whenever you're sending a message to anyone else on WhatsApp, you encrypt it using that guy's public key. So you took that public key, you will encrypt it, you send it to the server. Now server doesn't have the private key of that user. That's what it claims to. So
So
WhatsApp
you mean
says,
to say that okay, the application is the one which is going to give us the public key for individual user?
no. Every user, when they sign up on the WhatsApp platform, The
Uh-huh.
WhatsApp application itself on the phone will generate two pair of keys. One is the public key and one is the private key. So the private key will not leave the user's phone anytime. It will just be stored on the user's phone. The public key the user will share to other users of WhatsApp. So the server doesn't have access to the private key. So whenever I am sending a message to you, I will use your public key that WhatsApp server gave me, and the message will go to the WhatsApp server. But WhatsApp server won't decrypt it because it never took the private key of you anytime. Then it will just send you the message, the encrypted message, to your phone. And in your phone, you will have the private key. You will decrypt it.
It means you mean to say that okay, the private key always going to be generated by the phone, not by the
Yeah, correct, correct,
WhatsApp. Okay,
correct.
because even though okay, if I'm going to if WhatsApp says okay, it's going to use my public key and then to encrypt and then sign means okay, even there will be some other ways to decrypt by the WhatsApp server itself, is it? Because if they have a if they are going to give both private and then public key, if that is not okay, means okay, the private key is always depends on a handset or the phone, okay, which one we are using.
So the pair of keys that is generated
Uh-huh.
by the WhatsApp application. So the phone is independent of that. So the application will have its algorithms to create these two keys. So now what WhatsApp claims is it doesn't upload or download the private keys anywhere. It will just stay on the phone. That's what they claim. So the encryption is as secure as the theory behind it, right? So the theory is pretty solid. If the keys are secure, your data is secure. So if the private key leaves your system, you will know, right? Because it will go through the network. So now this security researchers they tested it and they actually found out that the private key doesn't leave your system because there are no
Good.
network calls through which the private key transfers over the network. It will just stay on your mobile phone. So I think it's pretty secure, but as you said, the those WhatsApp people have the absolute authority over the system. So they might they know the algorithm how they generate the private key, so they can use the same algorithm on their server to generate the pair. So they don't need
Why
to
why I
steal the
why I
private key.
got this question? Why I got this? Sorry to disturb. Why I got this question means,
Uh-huh.
as I see, I think maybe around last from maybe the 1 year back, when
Uh-huh.
WhatsApp came that okay they are secured one, but they introduced this particular encryption method. So we used to get a one message on our WhatsApp saying that okay, this particular person is encrypted with this particular.
Correct.
You remember okay, there was one message was
Yeah,
displaying
yeah, yeah,
actually.
yeah, yeah,
But
yeah, yeah.
nowadays, okay, we are not seeing that particular message. That's why okay, where I got this particular question.
I think that
Previously,
message was just for the marketing purpose because when you see that all your thing are encrypted, you will talk about that feature to other people and they will start using it. Now their marketing thing is enough. They're not seeing any new users, so maybe they stopped it because it didn't serve any purpose. So that could be one of the reasons. But
maybe the WhatsApp is used by the vast people. Okay, maybe some people are not much uh, think about the security of this one. So that's why they stop. I don't know. But still,
yeah,
I have a strong belief that okay, even they have a both keys means okay, they maybe do something. I'm not
yeah,
sure.
yeah. No, that could be the case because they are the authority. If they want to do something with your data, they will do it. You can't do anything because the data goes through their server. We are dependent on them, so
Yeah,
nothing
because the
can.
channel is based on them only. You can't do anything else.
Yeah, yeah, yeah. That is right. So, but I hope the whole process is clear to you guys because the applications of this asymmetric methodology are huge. It is being used like everywhere, literally everywhere. So I'll tell you where it is not being used. It's not being used to hash the passwords. When you sign up on a website, that password is stored on the server. So they don't use asymmetric encryption to hash or store that password, because they're not sending the password to anyone. They don't need to read it, so they don't you know create two keys for every user, then encrypt it and then decrypt it. So their use case is different. So I'll show you what's their use cases. So their use case is to make you log in and store the password securely on the system. So when you submit a password on the system, they will not encrypt it or use any kind of asymmetric encryption algorithms or anything like that. They just hash it. So this is not encoding, this is hashing. So no one can just directly decrypt the data using the same process. So let's say instead of hashing, I use the algorithm name. I'll say MD5. MD5 is a hashing algorithm. No, you will not get the password by just running the same algorithm on the encrypted data. This will just make it more encrypted. So if this was some random data that came out, this data will be more random, right? Because it's just running the same algorithm and it's running it twice. So no reverse process will be happening here. And that is what they want, right? They don't want to decrypt the password and read it anytime. So let's say you are a user, you submitted your password, they encrypted it and stored it on the system. So their use case is to know that when next time you enter the password, was it the same password or not. So instead of decoding your password and then comparing it, they can encode your password again, right? This time when you enter the password, I'll call it entered password, you will get again some encrypted password. So to know that this is the same password that you used to sign up, you will just compare this encrypted password and you will compare this encrypted password. If they are the same, that means you're the real user. That's how the authentication will work. They don't need to know your real password for that, right? So their use case is totally different. It's not a message that has to be read somewhere. They just need to compare the values, the end values. So that's why they use hashing in instead of any encryption or other techniques. So some years back, this was not very common. Nobody encrypted their password. Most of them will encode it. So as I talked about it previously, encoding is not for security, but they encoded it because they thought it will make it more secure. So every password dump. So whenever a hacker hacks a website, he will dump the whole database somewhere. So every database that was dumped some years back, most of them will contain these encoded passwords, or worse, they will contain the plain text password. They will not do anything. They will not hide it from anyone because they think that this password will remain on their server. No one will steal it. That was very insecure. But this case, is it secure enough? No, it's not. Because all you need to do is find a vulnerability in this algorithm itself. If you find any vulnerability in this algorithm, you can come up with another algorithm that will decrypt it. Because to come up with this secret password or secret encrypted password, this algorithm is running some kind of steps on this password. So if you can reverse engineer or reverse those steps from this, you will get this. So it's again a very mathematical based job to do here. There have been multiple algorithms that were thought of to be very secure, but things turned out to be the opposite. Many hashing algorithms that were very widely used some years back are not being used right now because scientists and researchers, they have come up with techniques that can reverse encrypt those data encrypted through that algorithm. So the thing to attack here is the algorithm. So let's say I don't have any, uh, mathematical knowledge. I don't understand this algorithm. I don't know what it's doing underneath the function calls. How do I, log into a systems without knowing the password? So it's easy. That's what we called brute force. The end goal here is to reach this encrypted password somehow, so that when it compares to the original password, it is the same, right? So I'm a hacker. I need to enter all the passwords, right? So my end goal is to log in into the account of a user, and I know that the user is logged in and the system stored the encrypted password. So even if I dump the whole database, I'll get a list of passwords, but I will not be able to make sense of any of those passwords. They will be encrypted. So I need to brute force. So I will brute force. I will have a list of. So if any of those encrypted passwords match this password, that means I got the password right, because some password in this list was encrypted using MD5 that gave a encrypted password same as this one. But is that feasible? Obviously no, because even if you have a supercomputer or billions of supercomputer and you had billions of years, you cannot crack the MD5 algorithm. It's built such as that. It's totally random. So even if the computers which can process a million instructions per second, even if I have billions of those computers, you'll still need a long, long time to process all the words, enough words, so that you can come up with this exact password. So it's not feasible. With our current computing resources, it's like not possible. So it's not worth it. So people still try to crack these hashes. If you just go and search for crack hashes, you'll get 10 websites that do it. Crackstation, Hashkiller, Online Hash Crack, and Project Rainbow Crack. So people are trying to do it. They have employed all the servers and lookup tables to crack password hashes. So if you can see here, they have written a line for MD5 and SHA1 hashes. We have a 190 GB, 15 billion entry lookup table, and for other hashes we have a 19 GB, 1.5 billion entry lookup table. This means they have a huge data set of words, right, of all the plain text passwords, to which they will compare this new encrypted hash. So even with all those resources, it will take a lot of time, possibly more than a million years to encrypt a complex enough password. But theoretically, it can be done, right? You just need a long, long time. Let's say you are lucky and the password that matched was the first password in the list. You don't need to go through the list of billion passwords. That password was, coincidentally or by luck in the first place. So you didn't require a billion years. It was done in 10 minutes. So theoretically, it's yes, but a long, long time, and with a luck, luck or some other factor, can be done quickly. So what's the, how do security researchers or the scientists tackle this problem? Because people can still brute force, right? Even if they require a billion machines or a billion of years, they can do it. So the answer is salting. With salting, they make the process much more harder. So what is salting? So salting is a random data that you add to the actual data before encryption or before hashing. So you had some data and then you had to pass it through MD5. This was our normal flow, but instead of data, we will add some randomness to it. Whenever we are getting a new password, whenever user enters a new password to log in, we will just add that salt again, this part, to every entered password, then MD5 hash it, and then we'll get a encrypted password. So process is same for encryption and comparing, but it makes the system safe to brute force. Because what the hackers were doing end of the day, they were trying to guess the word, right? Guess the word and match it with the list of words that they already have. So it's very less likely that they will have this word in their dictionary. Because if some user enters some normal English word like data, they will have it in their word. It's very common. But if we add some randomness to it, it will make it less likely. So as less likely that the MD5 algorithm being cracked was, this adds, a, this makes it more harder. So this is called salting, and this is called salt. So every secure website out there is using this. They just don't normally use MD5 alone or SHA1 alone. They will add a salt and then they will use the algorithm. So let's say your salt is breached. Again, as we talked before, the server itself can get hacked. And if the salt is stored on the server, then it will be, you know, gained by the user, and the user can, or the hacker can, add that salt to the list of passwords. To every password in this list, they will add the salt also in the end. So it makes the whole point of salting worthless. So what is the proper salting mechanism? So what do servers do right now? They don't store the salt anywhere. They come up with a salt dynamically. So every user will have a different salt. So there will be some property of that user that goes through an algorithm that gives a salt for that user, and then they attach that salt to the data that the user submits, and then they hash it, and then they encrypt the data. So making it much more random now. Every other user will have different salts. No salts will match. So even if one salt is breached, it will only be, it will only affect that user only. It will not affect all the users of the system. That's where salting is very efficient. It adds randomness over the already random process, and then it has the randomizing process for each user is different. The salt for each user will be different. So the random keyword that they add to the end of the data is different. So it adds a layer of security, and it makes it much tougher for the attacker to breach the system. It's like much more complicated than this, but this is the fundamental uh, definition and the fundamental overview of how these three things work: the symmetric encryption, asymmetric encryption, and hashing. And then we talked about salting. That makes the whole process much more hard and much more less prone to hack. Was that clear enough? So this was the OWASP top 10. So I'll just go through and explain in a bit detail, because these are the weak links. This is where the bugs are. This is where the Android application is vulnerable. And if you understand these and you know how to look for these vulnerable links in the chain, you'll be able to hack any mobile app out there if it's insecure. So first is improper platform usage. So let's say the Android application. So every Android application is built using the same functionalities given by the Android operating system, right? So some apps, some functions provided by that operating system, those functions might be secure, might not be secure. So there is some function that does the same job as the other function, but maybe that first function is less secure. When we talk about security, we talk about how the function handles data, or how the function gives permission to other functions to access its data. So every function's implementation is different. So some function that was not meant for your job, you're calling that in your Android application. That makes your application much more probable to hacks. Second is insecure data storage. So just like web applications, mobile applications also use the data that is entered by the user. They store it somewhere, usernames and passwords. So sometimes they will just store it in plain text, as we talked before, without encrypting it. Sometimes they will store it in a very insecure place where other applications can access that data. Right? There are multiple applications on the same phone. You don't want one application to access data of another application. Otherwise, your mobile game can access your WhatsApp messages. So that is not good. So data should be kept secure in the mobile device itself. Third is insecure communication. This is the same as a web application. When you're contacting or conversating with the web server, because a mobile application also talks to a web server, right? So it should use encrypted communication channels. It should not send anything in plain text. So same as that. Fourth is insecure authentication. This means somehow the hacker is able to log in the mobile app without knowing your password. He bypassed the authentication mechanism. This is same as login bypass in web applications. He will use some kind of SQL injection or something on the mobile app itself to log in without any authentication. So if you give your mobile phone to any other user, it's the same if he downloads WhatsApp, and if he is able to log in without using your password, he can access your data, right? WhatsApp server will just give him all the messages he can read and send message to anyone if authentication is not secure. So that's a very disastrous scenario. Next is insufficient cryptography. So whenever app stores something, let's say store some photographs of your WhatsApp chat, it should encrypt it so that no other, like the photo app or some malicious app that you downloaded, it can't access those photos. Otherwise it will just get all the photos from your hard disk and publish it somewhere on the internet, right? It can, if it has access to your mobile device. So the app must encrypt the sensitive data that is storing on the mobile device, so that no other app can just send it anywhere else. If they send it anywhere else, they won't be able to read it because it's encrypted. So this is what insufficient cryptography is about. Next is insecure authorization. Same as the authorization bypass in web apps. Let's say you gained access as a user in your mobile application. So now the same app may have a functionality to act as an administrator, right? Or maybe let's use the WhatsApp model. So in a group there are people who are admin, WhatsApp group admin, and there are WhatsApp normal users, normal group users. So a group user can't delete another group user from WhatsApp group, but an admin can. So the group user doesn't have the authority to delete a user or do sensitive stuff. But if he is able to bypass that for any Android application, let's say WhatsApp, he will become the group admin. He will do anything that an admin can. So that's the kind of vulnerability that we should test for when we are testing for insecure authorization. Next is client code quality. So again, a mobile app is just a you know bunch of codes bunch of source codes, bunch of SQL scripts. So those source codes can contain vulnerabilities, right? Maybe they will leave some keys in there in the source code, some API key or some hard-coded password in the source code itself, or maybe in the source code they use some function that is not very secure. So it depends on the code quality, how secure your application is going to be, because it's not like you give an APK. So whenever there's an Android app, right? Android app is bundled into an APK file. So if you give an APK to someone, it's not that he can't access the real code inside it. He can. There are tools for that. If I had more time, I would show you guys how those tools work. But let's continue right now. So using that tool, to that tool you give an APK, it will give you a list of source files, the real logic of that Android app. So in those Java files, you will find some tokens, you will find some URLs, some internal endpoints, some passwords, some API keys, everything. So if the developer leaves them there thinking that no one can get it from its APK, they are wrong. It's very easy. Next is code tampering. So sometime, when the application is running in, and the data will be in the memory. So whenever you get a message, some of it might be in the memory. So maybe some other application can access the same memory. He can read your password. So it's called dynamic, memory allocation. So where the app uses some device memory, some RAM, to store the data. So if it stores some data and some other, not only data, the code also. So app can run some code, that code be in the memory. So if some attacker or some other malicious app is able to alter that code, it will be disastrous. So that is very serious. So if you think about it, it's not that different as web application. It's the same. So there's an application, you have to hack it, and it has multiple components. If you understand those components well enough, you will be able to figure out which is the weak link in this whole scenario. Next is reverse engineering. This is again mostly the same thing as code quality, because by reverse engineering, people reverse the APK into the source file, then learn about how the application actually works, the algorithms. They may come up with some vulnerabilities that is very obvious from the source code itself, or they can track the actual servers that the application is using to communicate. So it's also very easy, and it's very common also. Next is extraneous feature. So sometimes the developer, he will add a feature in the app that is not open to the public. That is a hidden feature. Maybe it's a backdoor that the developer intended to have in the application, so that he can get access to the data of any other user without their permission, because it's the app that is making all the calls, right? So he can just add a backdoor to the app and download all the messages of that user. He can, because if the backdoor is possible, then anything is possible. So those hidden backdoors and those hidden functions can be exploited by the hacker itself. So it's like very dangerous, and these functionalities should be scanned. So if you get a mobile app, first of all you must convert it, the APK, to a bunch of Java files, Java source code files. Then you must learn a bit of source code analysis to understand what the source code is really doing. Is it doing it the correct way? Is it secure? Or is there any bug? Or has the developer left anything worth giving a look, like some uncommon function or some uncommon way of implementing certain technology. Let's say he's using an S3 bucket, an Amazon S3 bucket to store your photos. That is like not very common because developers store it in the mobile app itself, mobile device itself. So if he's sending some photo somewhere, he must have access to that resource on the cloud, right? That's how he's communicating to it. So maybe he has the keys hard coded in the application itself, in the Java files. If you go through the Java files, you might find a API password for that cloud service, and then you get access to the whole cloud service using that password. So that's how you should begin testing mobile apps. So these were the weak links we just talked about. There are multiple tools on it. I'll just write it here. There's one common tool called Carc. This decompiles the APK itself and converts the APK into Java files, Java source code. There's one more called JADX. There's one more called APK, no sorry, DEX to jar. You must learn and understand how these tools work and why do people use this. This is for beginner. For advanced, you can learn Frida. It's a dynamic and static analysis tool for Android apps. There are more, but I think this will be enough to cover the Android security part. I am just giving you an idea how these little technologies, because right now everything is coupled to everything else. So WhatsApp has a web interface and WhatsApp has a mobile app, right? So functionalities on the web interface and the mobile app will be almost the same, but they are not running the same code, same logic behind it. They have different implementations. The mobile app is running on Java source code into that is converted into an APK file, and the web application, the WhatsApp web, that is probably coded in PHP or anything else, right? So you must understand, like, if this functionality is working in X way on web, how could it work on the mobile app? Because most, like, both these systems, they are accessing the same data source. There will be a common database where they are fetching the messages, right? So if you want to hack the application itself, you can just directly go to the mobile app, decompile it, and you can find the location of the database in the source code itself, because the mobile app is talking to the same database. Now with a mobile app, you have access to the whole code of the application. In a web, you don't have access to all the code. You have access only to the front end code that usually contains nothing sensitive. So it's all coupled, the mobile app, the web app. But if you understand how they work along with the backend things like a database, then you can come up with scenarios how to hack these components and how to hack the database using the mobile app and much more. So these are links to hacking the single infrastructure, that is WhatsApp or any mobile app of that sort. So now the cloud security part also plays a vital role because everything is deployed on cloud. Maybe the database is running on cloud itself. Let's say an Amazon instance. So cloud, it's just a computer, just managed by a different entity than our organization. If it's running on cloud, we are not maintaining it. Amazon is maintaining it or Google is maintaining it. So we only get to talk to them, talk to those services. We talk using passwords and tokens that Amazon gives us. So we will, if you think about it, how to attack that. First of all, let's attack the whole service itself. Let's steal the passwords. I told you passwords or access tokens you can find in the mobile app itself. If it is hard coded, maybe you can find it in a GitHub repository that the developer pushed when committing the code. He had to remove the tokens from the files. He did not. He forgot. Now we have access to the tokens. We can access the whole cloud infrastructure of that company. So that's the most obvious place to hit the cloud security part. The other aspect is how those services are secure. So let's say Amazon has a database service called, let's say, RDS, that is just as a SQL database service that you host yourself. So you must know, how RDS is secure and how is it different security wise than the normal databases. It's not much different, just that since you're not maintaining it, you don't have access to the passwords, or you know you don't have access to the database password, or you're not the admin of the database. So the way you hit a cloud hosted database is different from a normal database. You don't have to get root access to the database by switching into the server, nothing like that. Only way you can hack those databases is by hack you know is by getting the credentials of that user who talks to those databases. How to get those? There are multiple ways. One is from the source code, one is from the configuration file, the other is from the server itself, the server that talks to that cloud service, the web server I'm talking about, the web server on which the web application is hosted. So that web server is talking to that cloud service to get the data or talk to that database, anything. So that server must have the credentials. So where are those credentials stored? So for an AWS service, the credentials are stored in .aws directory. How do I know that? Because that's where the standard directory is to store the standard AWS credentials. So once you know where these cloud services, when you install them, they store their credentials by default. You will know when you get the access to that web server where to look for those credentials to hack the cloud service. Once you know, you can try it on different servers. So these are the weak links. Now there are tools out there to do this. The most useful tool. So I'm talking about the AWS part because that's mostly what people use, and that's what I have used in a lot. So this AWS CLI tool. This is not a hacking tool. This is just a tool to talk to AWS service. But if you have some leaked tokens or leaked access keys, you can use it using the CLI or command line interface to talk to AWS. So it's very useful. And then you can, so one more cloud service that is like very vulnerable right now is S3. It's a bucket storage system where people store their data. So how to hack an S3? Just wait for the developer to misconfigure it. So the developer had to configure the database in such a way that, not the database, the S3 service in such a way that it is secure and nobody can read any data out of it without any permission. But since cloud is a very misunderstood, or people don't know, it's quite newer, right? Like it's not very traditional. So people mess up, they leave the S3 buckets open. So you can just go and access those S3 objects or the data stored in it. So that is easy. So for S3 testing, there are multiple tools I have shared before in the previous slides that you guys can use. This one, you can just search for S3 bucket finder space GitHub, and this is the S3 buckets boot force. So this will find S3 buckets, and then if any of those buckets is of your clients, then it is hacked because it might be open to read and write access. I think that's enough to hack AWS. Now the same thing is available for Google Cloud Platform also. You can just look for the counterparts and it will be available. So now system security is not much different. A system is just a system, just like your laptop or your desktop. Now to hack it, you need to know how is it kept secure. It is kept secure by passwords and access controls. So there are root users and there are normal users. A root user has access to everything. A normal user has access to limited things. So a normal user, if he wants to be root user, he must hack and fool the system to understand every command sent by the normal user and think that this command is from a root user. So it will have full permissions. So this is a vast field. I'm not going to talk much about it because I'm also not very proficient with system security. I'm still learning it. But I can tell you the places to start. Again, the OWASP place is again a very great resource to learn system security also. So I'll just search. So no, actually OWASP is you will find guides here to learn certain things. But as I told, OWASP is mostly targeted to the web interfaces. So it will not contain many things about system security, but as a guide to start, you can start from here. You guys can start from here. There are again top 10 best practices, buffer and stack overflow, injection prevention. I also don't know much about these, but if you want to learn, you can learn these, and you can start from these topics and start picking one of those, one by one. So I'm just going to talk about the theoretical links. So when whatever knowledge I have about system security, so mostly there's this platform. There's one cool platform that you must know. This Hack the Box. So this company or this platform gives you access to machines, servers, and then you you will have to hack into the server as a normal user. Once you hack into the server as a normal user, you have to escalate your privilege. You will have to hack into the root user. So there are multiple guides on the internet. You can just search for hack the box write-ups. In this GitHub repository, people write they hack certain box, and then you can read those guides and learn about it. You will start with the web application tools. Once you get a server, you will try to brute force it. So again, the web application tools will come in use here, like password brute forcer, web path brute forcer, or anything like that. So those tools, and then there are certain tools. Once you get access into the system, then you have to exploit buffer overflows, how the memory is vulnerable, how certain applications are vulnerable, how to trace their system calls, and much more. A lot of things that I possibly cannot cover here, but there are many things. So once you learn about those, you will get to know about the tools. So I don't see point talking about tools here, because we don't understand the concept well enough. Security is a whole different, part of security. Web application security is that we had this all this session about. So system security is something that, so who learns this? If I learn this, how it will be helpful? So this is for either the forensic people who wants to recover data, or want to know how a process or a malware infection, or how the malware you know replicated through multiple machines and compromise the whole network. So who want to understand the system, the network, they must be proficient with system security. So if you are interested in that, like decode viruses, understanding how they work and defeating them, then system security is for you. So let's move ahead. So I wanted to talk about malwares because it's a very hot topic right now. Everywhere you see there are mentions of malwares. So there are multiple types of malware. There are viruses, there are trojans, there are worms, there are rootkits, and there are ransomwares. And there are many more. These are the most common ones on. So a virus is something, you must have heard a lot about this class of malwares. When it infects your system, you don't have any other alternative than to clear that malicious software from your system. So why is it like that harmful? So a virus is, a piece of code that replicates. So if you get virus in your system, it will replicate into other files. It will infect all the other files and it will corrupt them, or maybe it will be, unreadable to you. But the main characteristic about the virus is that it requires human intervention. So unless you click on that is a virus, it will not spread. It requires your permission. You need to click it, you need to run it, and if you're a administrator or a root user, it will run with full permissions because a root user ran it. So it will infect everything. So now these viruses will infect other files, as I told you. They can also delete certain files, very sensitive files such as system files, some boot records maybe. So this will just make the system useless, because if it deletes some critical file, then your system is useless. The system won't start. Sometimes viruses don't do anything; they just sit and listen to your data and send your data somewhere. So it will just hide at least looking like a legitimate service or file, and it will just keep your data somewhere else. Next are trojans. So trojans, main characteristic is that they hide in the legitimate files. The file will look like a very file, but when you install it, it will show its real. So there are trojans that steal your data. There are trojans that destroy your data. There are trojans that destroy other services, other softwares, like your some payment service or something. Affect that. So a Trojan, looks like a normal file, very legitimate file, but it's not. It's doing something harmful. Worms, but worms are just like viruses, but they are not dependent on user intervention. Worms will just propagate themselves. So once a user have these worms on the system, they will just replicate everywhere. They don't need your clicking or running. And not on your system, it will propagate to others also. So whatever device is connected into your network, it will go into those devices also, if proper permissions are provided. Now there are rootkits are much more dangerous, because once you get a rootkit in your system, it will directly affect the critical parts of the system. Like it will bind OS, or it will affect some operating system file and make the system very vulnerable. You can't just install a antivirus and delete the rootkit. So you need to format the whole system, because antivirus will not have access to delete those rootkits, because those rootkits will be in much more privileged parts of the system. So antivirus won't have permissions to go there. There are ransomwares. Ransomwares get on your system, encrypt all your data, then ask you to give them some money, so they will decrypt it back. Now we know, Python is very difficult. Like when you encrypt data and send it somewhere, it's almost impossible for the other guy to decrypt it without knowing the token or something that was used for encryption. So if some malware comes and encrypts all your files, how are you going to decrypt it? It's just not possible for you as well. So it will be very very harmful. So how do you deal with this? Let's say you're a security professional, because everybody knows, how this malware and everything. But you're a security professional. How do you deal with them? What a normal user would do is, whatever he is infected with, he will install an antivirus. He will install a firewall, and then he will deploy systems to clean his system, right? But you're a security professional. Your goal is not just to clean your system. Your goal is to understand how those malicious piece of code are working. So you study those malwares. How do you study them? You will have two ways of studying them. First, studying the code of that malware itself. So malware is just a piece of code, right? It's just following some instructions written in the logic. So you will download that malware, you will open its source code, and you will read how it is working. You will try to make sense is how it is actually affecting the system. Once you understand it, you will know how to stop it, right? You might come up with an idea. Okay, this malware is using this little vulnerability in my system. So if it's that vulnerability, this malware will be useless. It will not be able to do anything. And that's how the security professionals actually patch the systems against these malwares that keep coming up every day. And there's the other way. Say, you are not able to locate the real source of the malware, because the malwares are very good at hiding their whole file or their components. So you might not be able to see the whole picture. What you do in that case is you let the malware run. You don't run it in your system, you run it in a sandbox environment. An environment which looks like your system, but it's not. It's an environment inside your system that is totally excluded all the files and all the system things. So you let it run that, and then you track it, what it is doing now, what network call is it making, is it sending my data somewhere, what function is it using to send that data. So you understand how it is working instead of reading its code. Once you figure out, okay, making this network call, so what if I block that network, so that it's not able to connect to it. My system gives it no permission to connect to that network. If that happens, then your malware is useless again. Even if it runs on it will not be able to do anything, because you know made it to by patching something inside your system. The second, dynamic analysis to let the malware run is very dangerous. Those malware writers, they know that people will try to understand it, put them in sandboxes. So maybe they have thought of it, and they will somehow buy a sandbox and gain the access to the system again while you're trying to understand it. So it's very dangerous. Like, if you're not sure, you should not, because most of these malwares have actually uh, were able to escape the sandbox environment. So that's how you should approach the malware testing and malware patching as a professional. To be a good malware analyst or a malware engineer, you have to be good at security, because that is where the malwares attack. They attack the system, attack the operating system, right? So you must learn system security for it. But I think with much knowledge about them, you should be able to figure out how to start and to begin if you want to pursue this field. So blacklist here. Let's say you have a domain. So let's say
Uh-huh.
there's a domain that sent you a mail. Like, it's spamme.com. So
Uh-huh.
you can just come here and you can search if that is in the blacklist or not.
Uh-huh.
So it will check. in 5 seconds it will give you answer, is it spam or not. So it will say it's
Uh-huh.
not listed in the DBL. So I will you use some spam house plugin over your mail server, so that whenever an email comes, you pass it through spam house. If spam
Mhm.
house gives it a check mark like, okay, clean, this email is not in the blacklist, then let it
Mhm.
go to the mailbox. Then you will not have to worry about any spams or anything. Only those mails
Oh.
will come that are, okay with spam house.
What if, okay, if that particular domain is not listed in a blacklist, it's still, I just
Then,
want to know whether that website is there, that particular domain is there or not. That's the only thing.
so let's say you get a domain and you want to know if any website or anything is on it or not. You can just dig it
Uh-huh.
in google.com. So if there's a website on it, it will have an IP
Okay.
address. So Google has an IP address. So some website could be
Okay.
there, but let's say this will not have an IP address. So
Uh-huh.
this doesn't exist. So it's that short. You don't have to use who is on it. So that is easy. But I'll suggest you use some kind of blacklist, because these spam campaigns, they don't target a single user. They will target
Uh,
millions of users over the world.
yeah,
So
yeah, yeah, yeah.
any one user, if he puts such name into a blacklist, you can just query that blacklist and save.
Okay, then I'll try on Monday actually.
Yeah, yeah. So or you can contact the Rackspace people and ask if they have an integration with any blacklist or something. So
Yes,
that
I'll do that.
yeah, yeah, sure.
Okay, then thanks for your suggestion.
We hope this comprehensively put together full course video was of complete use to you guys. Well, if you have any questions, any suggestions, and anything in general as well, make sure to head down to the comment section and do let us know. We'll be more than happy to help you there. Well, with this, I wish you well and I'll see you on the next one.